Okay, hello to my grade 11s, but also I guess you could say grade 10 simultaneously. Guys, today I'm just gonna jump between exponents and products of binomials, trinomials, monomials, and all of that stuff. So we're just gonna move between exponents and products of binomials, trinomials, and stuff. And I know it's New Year's, it's what you call. I know it's some of you are just gonna be coming into this live and telling me a lot of things about the fact that it's Christmas Eve and stuff. Guys, sure, I've heard it all. Thank you so much. I appreciate the update, but I don't really appreciate it. So yeah, I'm just gonna flow and move. So guys, we are still going to be flowing with exponents today again. This is relevant for which grades? All grades. So please don't ask me which grade it is, because it's relevant for all grades. All grades will benefit from this live because we are dealing with algebra, and specifically we are dealing with the exponent part of algebra. Okay, so I'm just gonna do a few problems there and there. You guys are more than welcome to comment in the comment section. You can comment with whatever you want. You can gift as much as you want, guys. I appreciate the gifts when they do come, so feel free to gift when you need to gift. Double tap on the screen, get the likes for the live up there so that we can have more people joining the live. More people might need this than meets the eye. So yeah, let's do it. Let's get the party started. Right, so we are still working them exponents, and we are still fundamentally focusing on the basics. All right, because we basically know what the laws of the exponents are. We've looked at the laws of exponents. Now we are just applying the laws of exponents to various problems so that we can see that we understand the laws of exponents well. Okay, so I'm just gonna pick it up from where we left off from yesterday, and yeah, let's take it one problem at a time until we get to more complex problems. Okay, so the first problem today is 2pqr to the power 3 everything over 4pqr. I think this is where I ended off yesterday, so we're just gonna pick it up there on that note. Right, remember guys, yesterday we looked at the fact that we must know BEDMAS. All right, because whenever we are dealing with a simplification of a problem and it involves different operations, we must remember brackets, we must remember exponents, we must take into consideration division, we must also think about multiplication, we must also take into consideration addition, and then also consider subtraction. And something to note is that whenever there are brackets, first you take care of what is in brackets, then you look at exponents. And if there are exponents, guys, yesterday I spoke about SNL as it relates to our movies, but more specifically as it relates, okay, to sign, number, and letter. Okay, right, sign, number, and letter. Exactly, since it's one term, we distribute the exponent. Okay, since it's one term, we distribute the exponent. So like I said, guys, if we look at this exponent, all right, we can distribute the exponent to the what? To the sign, the number, the letter, if only the relationship that we see with the term inside the bracket is one of multiplication. So obviously then, because brackets exponents, we know that bracket, the exponent is our priority, BE. Okay, so we distribute the exponent. How? We say 2 to the power. Now there's a 1 there, there's a 1 there, there's a 1 there, there's a 1 there. We can't see it, but it's there. So it's 1 times 3. You distribute the exponent to the exponent of 2. P to the power 1 times 3. You distribute by multiplication the exponent that is external to the bracket. Q to the power 1 times 3. R to the power 1 times 3. So all in all, what we are saying is that if the relationship between the bases is one of multiplication, because this 2 and this P and this Q and this R are combined together because of multiply. Okay, we don't see the multiplication sign, but that's what combines 2P, Q, and R. And therefore, this is one term. We can distribute the exponent if it's one term inside the bracket. We cannot do that. We cannot distribute the exponent if there's 2 or more terms. Does that make sense? We only distribute the exponent if there is only one term. And this is what is important about when we are dealing with this order of operation. We look at brackets, we see exponents. We can only distribute an exponent if there's one term. Okay, and this is referred to as a single term. 2PQR is one term. All right, so that's why we distribute the exponent according to the what? The sign. Remember guys, this 2 is positive. So obviously an exponent 3 applied to a positive sign keeps the sign positive. It's like if there was a negative sign here, the exponent 3, because it is odd, when applied to a negative sign, it keeps that sign. So an odd exponent keeps whatever sign is there, but a even exponent will basically change the negative sign, but obviously retain the positive sign. In other words, a positive even exponent always leads to a what? A positive sign if there is one that is there next to the coefficient or the number, right? So that's basically how we deal with that. I hope it makes sense. And this is very important. Basic as it is, so important. In the denominator, this denominator is not affected by the exponent 3. It's just independently there on its own, minding its own business. Now we go and apply the multiplication. So that's 2 to the power 3, P to the power 3, Q to the power 3, and R to the power 3 over what? 4PQR. Then of course we now apply the exponent. Remember, the exponent means how many 2's multiplied together? 3 of them. So 2 times 2 times 2, that gives me what? 8. P to the power 3, Q to the power 3, R to the power 3 over 4PQR. So we have now taken care of the brackets together with the exponent. Okay, I hope it makes sense. Now we look at the next operation. Now we can see that there's a relationship between 8P to the power 3, Q to the power 3, and R to the power 3 with the line, this line here means divide. So we are going to now divide. Remember, when we think about division, we also think about sign, number, letter. We are going to divide 8P to the power 3, Q to the power 3, and R to the power 3 over 4PQR. When we divide, what do? We divide the what? The sign. So this is a positive divided by a positive. What is a positive divided by a positive? School is closed, but our minds are opened. School is closed, but the mind is opened. And what a beautiful Christmas gift than for me to actually be coming down the chimney right now and giving you some content mathematics content, because the mind is not closed. Schools might be closed, but the mind is opened. So positive divided by positive, guys, gives us a positive. So the sign is taken care of with the division. We move on to the next thing. N means number. We divide 8 divided by 4. What is 8 divided by 4, guys? A positive what? What's 8 divided by 4? 8 divided by 4 is equal to... So we have established that the sign will be positive. But 8 divided by 4 gives us a what? Thank you, MX. It's 2. Okay. So in other words, you might see some people do this. Between 8 and 4, the highest common factor is 4. 4 goes into 8 how many times? 2 times. Then 4 goes into 4 how many times? Once. So that's why sometimes you'll usually see people writing 2 over 1. Because 2 over 1 is the same thing as what? As 2. Are we together? I hope that makes sense. We move on from the number. Remember, we're still dividing. So we've taken care of the sign. We've taken care of the number. Now we move on to the letter. P to the power 3 divided by P. Remember, when we are dividing the same base with letters, what do we do when we are dividing same bases? When the bases are the same and we are dividing, what do we do to the exponents, my beautiful, amazing maths gamers? Of course, when we are dividing same bases, what do we do to the exponents? We keep the base there in the numerator. Then we subtract the exponents. Remember, the P here has the exponent 3. The P there has a ghost exponent, which is 1. So we don't ever forget to write P to the power 3 minus 1, because when we are dividing same bases, what do? We keep the variable base. We subtract the exponents. We move on to Q. Q to the power 3 divided by Q. We keep the variable base there in the numerator. We subtract them exponents. Remember, there is 3 and there is a ghost 1 there. What do we do when we are dividing same bases? We keep the variable base in the numerator. We subtract them exponents. Right? Now 2 divided by 1, guys, is 2 there in the numerator. So we can actually let go of that 1 in the denominator, because there are no variables that are going to be situated in the denominator. All of our variables are going to be situated there at the top with the numerator. So the 2 divided by 1 gives us 2. So that's P to the power 3 minus 1 gives us P squared. 3 minus 1 gives us Q squared. R minus 3 minus 1 gives us R squared. And that is our final answer. 2P squared Q squared R squared. And guys, wasn't that just simple, straightforward, and to the point? I hope you see how straightforward and simple this was, guys. And this is what is important for us as grade high school learners, grade 8 to 12. You should be able to comfortably simplify an exponential expression of this nature without any problems by applying your understanding of BEDMAS. Start with the brackets, as BEDMAS seems to suggest. But if brackets are sorted, you look at the next thing, which is your exponents. And when you look at your exponents, if your exponent has one single term inside the bracket, like you see here, then you can apply or distribute the exponent to the sign, to the number, to the letter. So exponents, S and L. You distribute the exponent to the sign, which is positive. It gives you a positive answer. You distribute the exponent to the number, which gives you 2 to the power. There's an exponent 1. You multiply 1 times 3. You distribute the exponent 3 to the letter P. P to the power 1. You multiply 1 times 3. You distribute the exponent 3 to the exponent of q, which is 1 times 3, you distribute the exponent r3 to the exponent 1 times 3 for r. And that basically sorts out your distribution of the exponent according to the sign, positive, the number, 2 to the power 1 times 3, the letters L, P, Q, and R. For what? For one term. You don't do it for more than one term. You only do it if there is one term, as you see here. Look at the denominator, not affected by the exponent, so we keep it as it is. Then what's 1 times 3? It's 3, 3, 3, 3. Then what's 2 to the power 3? In the numerator, we have 8, because 2 to the power 3 means 2 times 2 times 2. That means 8. P to the power 3, Q to the power 3, R to the power 3. You keep that 4P, QR in the denominator as it is. Then finally, what is the relationship that we have between these two? It's one of division. You go to BEDMAS, the next thing after exponents is division. But when you divide, don't forget what? Sign, number, letter. You divide the sign, you divide the number, you divide the letter. There we have it. Positive divided by positive gives you a positive answer. That's the sign. The number 8 divided by 4. Remember that between 8 and 4, the highest common factor is 4. 4 goes into 8 how many times? Twice. 4 goes into 4 how many times? Once. That's the number taken care of. You move on to the next thing, the letter. P to the power 3 divided by P. When we are dividing same bases in exponents, what do we do to the exponents? We subtract them. So that's why you have, say, P to the power 3 minus 1. The P in the numerator. Why not the P in the denominator? Because it's 3 minus 1 in the numerator. Very important, guys. It's Q to the power 3 divided by Q. It's 3 minus 1 in the numerator. And then lastly, R to the power 3 divided by R. It's 3 minus 1 in the numerator. Then ultimately, what's 2 divided by 1? We can just write that as 2. Then we have P squared, Q squared, and R squared. The reason why this 1, we basically don't write it down, is because for the denominator, it's okay. The 1 holds no significance. But if the 1 was in the numerator, the 1 holds significance. We would have to actually make sure that the 1 appears. But in the denominator, not really. And as well, we can see that there's no variable that is actually going to be placed in the denominator. So that 1 can just not be there. Then we write 2P squared, Q squared, R squared as our final answer. And that's it. So guys, BEDMAS. You think BEDMAS is not important? It is. Brackets, exponents, we remember sign, number, letter. Division, we remember sign, number, letter. Also guys, if there's multiplication, we remember sign, number, letter. Guys, if you can just get this, I'm telling you, you'll have no problem. Exponents, division, multiplication all require you to consider your sign, your number, your letter. You distribute the exponent to the sign, the number, the letter. You divide, sign, number, letter. You multiply the sign, the number, the letter. You should be fine. Then addition and subtraction, you simply add and subtract. Okay? Simpiwe soil. Ndoda xolela lezingane. No. Wena, you should be the one that should be saying that. No. The person that needs to be forgiven is you, my friend, for saying what you are saying. I will forgive you. Okay? We have a crisis here in South Africa, and when you think Christmas is okay, that we don't do maths, hey, what's wrong with these people here? We have a crisis. And when you have a problem, no. Let's continue. Okay, can I just get if I can just have 3 people in the comment section that will say, thank you sir, we appreciate what you are doing, I will continue. But if not, I will stop. Onga, I will not teach log, my brother. Sorry. I'm sorry. No, Simpio, I won't, Mr. Soy. I won't 2 January, near. Thank you, Amo. I've got you there, my Lona, my Amo Lona. When you are the son of the soil, Simpiwo, you're probably enjoying many things. That's why you do not see the importance of this. Thank you so much. All right, let's continue, guys. Next problem. Okay. Please, guys, do double tap on the screen. Let's get the live out there. Let's harass people in the FYP page. I believe this is going to harass a lot of people in the FYP page. Unfortunately, those who are scrolling through live sessions, when you guys are double tapping and we get the live with many likes, then it's going to appear in the FYP. People will start joining in whether they like it or not, and we can get some traction to this thing. So you also help me out when you do that. So please continue to double tap on the screen, like the live, send me your daily heart me if you can. A rose is appreciated, or any other gift is appreciated if you are in the position to so do. It is much appreciated. If you guys are saying it's Christmas and you are feeling all Christmassy, then what better way than to gift me here in this live session? Yeah, that's the only Christmas that we are talking about here, no other. 8x to the power 0 times. Okay, so let's be clear what we're seeing here. This is 8, this is a x to the power 0. This is a multiplication sign. We have a bracket, 8x. This is x not multiply. It's raised to the power 0. Okay, so let us now see what is happening here. 8 I is just 8. X, on the other hand, has an exponent 0. What is the relationship between 8 and x? 8 and x are multiplied, guys. So what we can do is we can actually write in the place of x to the power 0, we can write what? 1. Okay? Brackets in maths mean multiply. Dot in maths means multiply. Multiply means multiply. There are a few things that mean multiply. This means multiply, a dot in maths means multiply, and brackets in maths also mean multiply. So these are the three things that mean multiply. They mean multiply. So if you want to indicate multiplication, you can use one of three of these symbols. So if I say 8 bracket 1, that means I'm multiplying. X to the power 0 is equal to 1. Any base raised to the power 0 is 1. Then we multiply. Now here, guys, you can see this 8 and this x have a relationship of multiply. This is a bracket, this is a 0. This is 0. Obviously, when we apply the exponent, we apply it according to the sign, the number, the letter. Does that make sense? We apply the 0 according to the sign, the number, the letter. So if you apply the 0 to the sign, it's still positive. If you apply the 0 to the number, it's 8 to the power 0 on its own. And if you apply the 0 to the x, it's x to the power 0 on its own. That basically leads us to what? 1 times 1, which is actually equal to 1. So in other words, we can actually just write in this bracket 1, because everything is affected by the 0. Here, it's only the x that is affected by the 0. That's why we write 1 for the x alone, not for the 8, because the 8 is left unaffected. But here, the 0, because the bracket is over 8 and x, it means the 0 is applied to everything. That's why the answer is 1 here. Then, we just apply. What's 8 times 1? That's 8. Times another 1, that is 8. So the answer is 8. Okay, we good, guys? Good, fine, sweet, sharp. So let's always be mindful of where the 0 is being applied. Okay, here the 8 is not affected. X is affected by the 0. So what happens to it? Changes to 1. 8 and x both affected by who? The 0. Why? Because of the bracket. So that's why the whole thing becomes 1. Do you see that, guys? Then we say 8 times 1 times 1. Because 8 times 1, that's 8. Times another 1, 8 times 1. That's obviously going to give us 8. Okay? I hope that makes sense, guys, and we are clear about it. Can we move on? Next problem. Actually, So you bring up a very important point there. Okay, you bring up a very important point. Let's do this. Okay, I've just added you as moderator, so you can help me out with that as well. Thank you so much. Thank you in advance. I've just hired you. You are employed. Okay, number 3. Next. Okay, let's look at this. This is 3 squared times AB plus brackets 2 to the power 4 a squared b squared all raised to the power half. Okay, so when we first look at this expression, we need to first establish a few things. What do we see here? We see 3 squared. It is multiplied with AB. Okay, then we have a plus sign. Now this plus sign separates. So we have one term here, and this is considered a single term. Why? Because 3 squared times AB, the relationship between the coefficient and the variables is one of multiplication. So this is one term. Remember, multiplication combines terms, guys. So this is one term. The plus sign here separates this term from this one. Does that make sense? So that's why it's important to look at your expression before you jump in and you start answering the question. It helps you out a lot when you do that. So we can deal with this separately and deal with that separately. But when we do, we don't forget what? Bad mass. Okay? You don't forget what? Bad mass. Very important, guys. We don't forget this. So let's come here then. 3 squared times AB. Okay? Alright, so I'm sure you guys can see what that will lead us to. 3 squared times AB can definitely take care of that on its own. That leads us to 9AB. 3 squared is 9 times the AB just gives us 9AB. Does that make sense? Then on the other side, we have a bracket with a exponent. We have a what? A bracket with a exponent. So then that means we need to go to bad mass. Brackets, then exponents. Bracket, then an exponent. It means the exponent needs to be applied to the bracket. But we only apply it if it's one term. Do we have one term inside this bracket? 2 to the power 4 a squared b squared. Yes, we do. Because this 2 to the power 4 a squared b squared has a relationship of multiplication which combines this together. So this exponent half can be applied. We apply it, the exponent, using S and L. So half applied to a positive sign still leads us to a positive answer. Half applied to the number gives us 2 to the power 4 times half. We multiply half with 4 for the number. Then we go to the letter a to the power 2 times half. We multiply the half with the exponent 2. b to the power 2 times half. We multiply the 2 for b with the exponent half. Okay, so these are important, guys, because we've just now applied bad mass for this term. And then we move forward and we simplify for this individual term. So 9AB plus. Let's go. What's 4 times half? All right. What exponent will that lead me to for 2? 4 times half gives me, I'm going to have 2 to the power what, guys? Thank you, Tlochi. I'm going to have 2 to the power 2. Then 2 times half. Thank you, 2 squared. We are going to have 2 times half. 2 times half gives me what? A to the power 1. Thank you so much, guys. You guys are amazing. So whether you write a to the power 1 or you choose not to actually reveal the exponent 1, that is fine. Then 2 times half gives us b to the power 1. Now, guys, I'm sure now you can see what I'm sure you can see. We have just addressed the b and the e for the second term. For the first term, it was just straightforward. We had 2 squared times ab, which is 9ab. So this was very easy, right? Then we have 9ab plus, what's 2 squared, guys? 2 squared gives us 4. And then this a, b. What do we now see in our expression, guys? Thank you, Remo. What do we now see in our expression? 9ab plus 4ab. Looks like 2 kids that have the same uniform, if you ask me. Okay, it's like 2 kids that are wearing the same uniform. We call these 2 kids that wear the same uniform, what do we call them? We call them like terms. What is the uniform? The uniform is AB. AB. Why do we say the kids have the same uniform? It's because this A has the same exponent with this A. This B has the same exponent as this B. We know the exponents for each A and B are 1. So basically we say that they have the same exact uniform. What do we do to kids that have the exact same uniform? We can add or subtract them, which is why, guys, if you come down here, for addition and subtraction, when it comes to our terms, we can add or subtract like terms, but we know if the terms were unlike, we would leave them as they are. Okay, does that make sense, guys? So if we are talking about addition and subtraction, we know we can only add and subtract like terms, but if it was unlike terms, we would leave the answer as it is. So for this particular one, when adding like terms, what do? We keep the uniform. In other words, we keep the variables as they are. So in other words, AB is going to be part of the answer. Then what do? We add or subtract the coefficients. In other words, we add or subtract the children of that particular school. 9 plus 4, that gives us 13. So the answer, guys, is 13AB. These kids that had the same uniform still have that particular uniform. It does not change when you are adding or subtracting. But then what changes? It's the coefficient, the number before the variable. 9 plus 4 is 13. So when we are adding or subtracting like terms, we keep the variables and we add or subtract the what? The coefficients, the numbers before the variable. This is what I need to sensitize you guys to, that exponents SNL, division SNL, multiplication SNL, but addition and subtraction, it's a matter of checking. If we have like terms, we can add or subtract them. But remember, if they were unlike terms, we would leave the expression as it is. Those are children that do not have the same uniform. Children that don't have the same uniform stay separate and apart. When you go to your school with your uniform, I go to my school with my uniform. Nom, SNL simply means you consider S means the sign, N means the number, L means the letter. All right, you consider the sign, the number, the letter. So for instance, we looked at this problem earlier on where we were dividing this with that. This is division, but when you divide first, you consider dividing the sign. That's why I say you divide, consider the sign as the sign. Then you divide, you consider the number 8 divided by 4. Then next you divide, you consider the what? The letters. When you are dividing bases with the same, you subtract the exponents. That's what I'm saying by SNL. SNL simply means you consider the sign, the number, the letter. So for exponents, division, multiplication, you consider the sign, the number, the letter. This is what I'm trying to get to you guys. And if you guys could grasp this for your algebra, hey guys, this is one of the things that will make your maths journey beautiful and sweet. Okay, then with addition and subtraction, we check, are there like terms? We are no longer talking about SNL with addition and subtraction. With addition and subtraction, we check, are there like terms? If they are like terms, I can add and subtract them. If they are unlike terms, then I know I leave those unlike terms as they are. Does that make sense? Okay, right. So that's why this guy is busy doing this with you. He is trying so hard to make you guys become more sensitive to the basics. Just the basics, guys. Just the basics. Hey, let's look at this problem. Let's look at this one. So look at the expression again. Take note of the how many terms you have in the expression. It's very important to establish that. Remember here, it was very easy for us to say how many terms do we have in the expression. We could see that this is one term. Why? Because 3 squared times AB is combined. Multiplication combines terms. So this is one term. The plus sign acts as a separator of terms. So this plus sign separates this term from this one. So here we were able to establish, okay, there are 2 terms. So deal with each term on its own using BEDMAS. Here we have an exponent. We deal with the exponent. We multiply. We have 9AB. Here on this side, we deal with the bracket exponents according to BEDMAS. Brackets exponents. Okay, right? So remember, when we are simplifying, simplification in this particular instance does not need us to factorize. When we are simplifying, we want to basically get the answer to the most simplest form possible. So for instance, if I'm here and you're going to say, let's factorize. Factorizing is not really assisting me with simplifying my answer. All right. Factorization has its role and we utilize it when we are asked explicitly factorize the following problem, or we utilize it when we have to simplify algebraic fractions where it is evident that in the numerator and the denominator there is possible factorization that can lead to further simplification. All right, so here it is not really needful. All right, okay, let's look at this one now. How many terms do we have here? Okay, so you can see there is 3 into x plus y to the power 0 times 2. This here is one term, all of it, because brackets also combine terms. All right, then you have this plus 256 to the power 0. Obviously, this is another term, plus 8k to the power 0. This is your third term. So there are 3 terms in this expression. Now we need to simplify this, right? So if we look at our first term, what can we do there? The 3 is untouched by the 0. So the 3 can just be written. But x plus y, everything here is raised to the power 0. So we don't apply the 0 to the individual variables. We can't do that. But because the 0 is outside this entire expression, which is inside the bracket, it means the entire thing becomes what? What does it become, guys? The entire x plus y becomes what? Because the 0 exponent is there. This whole thing becomes what, guys? What does it become ultimately? Thank you, Siand. It becomes 1. You see? Yeah. You cannot do this. Let me just show you something, guys. This is wrong. We don't do this with this. We don't do this. This is absolutely wrong. Why can't you distribute the exponent 0 to x and y? You can't do that because there is a plus sign between x and y. This plus sign separates x and y, so you cannot distribute 0 to the x and to the y. There is no law that says that. Okay, the distribution of an exponent only works when the relationship between the bases that are there is one of multiply or divide. If it is multiply and divide, then you can distribute the exponent to each individual base. But when the terms inside the bracket, guys, are separated by a plus and a minus sign, you cannot distribute the 0 to the what? To the individual bases. As I said yesterday, it is absolute nonsense to do this. Yes. Ki nonsense, ki nonsense. Okay? This we do not ever do. This is wrong. Because what would it lead actually? X to the power 0 would be 1, y to the power 0 it would be 1, and the final answer would be 2. Do you see why this is wrong? So we do not distribute the 0 when we have a plus or when we have a minus sign inside the bracket. We don't distribute. If we can see that the bases are separated by a plus and minus sign, we do not distribute the exponent inside the two individual bases. We don't do that. This, guys, is unacceptable. It is wrong, wrong, wrong. Ki nonsense. Right? I want you to forever remember, with addition or subtraction between our bases, we don't ever distribute the exponent to each individual base. We don't do that. Where there's what? Plus or minus between the terms. We only do it when there is a multiplication and division. Then we can distribute. As you can see here, the 3 we are able to distribute to the individual bases because 2, P, Q, and R have a relationship of multiply. It can be done. All right? It can be done. That's why this half can be distributed to the individual bases, because the relationship between 2, the A, and the B is one of multiply. I hope it makes sense, guys. So let us separate nonsense, okay, from legit stuff. Okay? We know that the answer here is not 2. It's rubbish to think that. Okay? Okay, I hope you understand. So that's why here, me says to you, x plus y to the power 0. What is that? The whole thing becomes 1. The whole thing, guys. The whole thing. All right? Then let's come here. After applying the 0 to the x plus y, we get 1. There's the multiply by 2. So we write that multiply by 2. It's still there. It's not going anywhere. We'll deal with it later. But at least now we have a more simplistic term that we have basically gotten from actually looking at just this individual term on its own. Let's move on. Plus. Now, guys, with numbers, this is 256 to the power 0. The entire number. Guys, this 0 is not just applying to the 6. Okay, I just want to say, let's say if you have xy to the power 0, and then you have 256 to the power 0. I just want to say that here, The variable x and y have a relationship of multiply. This is like saying x times y. Remember, right? This is like saying x times y. So the 0 is only applied to the y. That's why here we say the answer is x times 1, which is x. Because the relationship between x and y is one of what? Of multiply. The number 256 is the actual number. It's not 2 times 5 times 6. Okay, this is 256. It's all raised to the power 0. So the entire thing then becomes what? 1. This 0 is being applied to the number. All right, so let us see the difference. There's the difference between x, y to the power 0 and 256 to the power 0. Okay, yes, 256 is a number. Okay, it's one number, whereas xy is two variables multiplied together. And because the 0 is on top of y alone, we apply it as being on top of y alone, not as being on top of x. 256 as a number, the entire number is raised to the power 0, so it is all going to be equal to what? To 1. I hope it makes sense, guys. Okay. So if xy is one term, it means xy to the power 0, the entire thing, yes. If you see, this is different now. We have xy to the power 0 here, guys. All right, the 0 is on top of y alone. What's the relationship between x and y? It's multiply. So it's like saying x times y to the power 0. What is that? It's like saying x times 1, which is equal to what? To x. Okay, does that make sense, guys? But if you had xy to the power 0, the entire thing, remember, guys, now we are actually applying the 0 to everything. This now would be just equal to what? To 1. Better explained as well, we can distribute the 0 to the x, which is x to the power 0, distribute the 0 to the y times y to the power 0, because the relationship between x and y is multiply. And what does that lead us to? 1 times 1, which is also equal to what? To 1. So this is 1 in the same thing. Okay, 1 in the same thing. But 256 is a number, guys. This is not, 256 is not 2 times 5 times 6. If it was a situation of 2 times 5 times 6 to the power 0, then of course this would be 2 times 5. 6 to the power 0 would be 1, and then we'd say 10 times 1 is 10, if this was the situation. But this is just the entire number, 256 to the power 0. Okay, does that make sense, guys? Yeah. So let us keep that to mind. Say help, what do we say if it is x minus y to the power 0? Remo, x minus y to the power 0. Remember, what is separating x and y? It is a minus sign. But remember, because the bracket has encompassed x minus y and it's all raised to the power 0, then it means x minus y to the power 0 is simply going to be equal to what? To 1. Okay, does that make sense, guys? X minus y, the whole thing to the power 0, simply is going to be equal to what? To 1. But we dare not do this nonsense of saying x minus y to the power 0, then we want to go ahead and do this. This is nonsense. We do not distribute an exponent over a plus and a minus sign between terms. We don't do that. We do not distribute a exponent over a plus and a minus sign between terms. We don't do that ever. So you must always ask yourself, how many terms do I have inside the particular expression? If there are 2 or more terms, guys, we don't distribute the exponents. Okay, but if there's one term, like in this case, 2pqr, how many terms inside this bracket? How many terms inside 2pqr? Inside this bracket, there's only one term. 2p, q, and r is combined, it becomes 1. Raised to an exponent, it means we can distribute the exponent by multiplication for each individual base. Does that make sense? But when there's addition and subtraction, we dare not do that. This is absolute rubbish. This we don't ever do, because there are two terms we can't distribute the exponent. Never, ever, ever. Okay. Guys, I'm just trying to clarify, because I'm telling you now, learners who are in grade 12 don't get these basics and they mess up. And it's painful to my heart to see grade 12 learners messing up basic things that they should have understood in earlier grades. So 256 to the power 0, guys, is simply going to give us what? 1. Okay. Then we go on to 8k. Remember, guys, 8k is like saying 8 times k to the power 0. Who is affected by the exponent 0? Is the 8 affected by the exponent 0? Or is it just the k? Or are they both affected? Who is affected by the exponent 0 here? Okay, because we are going to say plus. Mbali, it's only k that is affected, guys. Only k is affected by the exponent 0. It can't be both. Okay? Okay? Please, guys, understand the difference. Okay? 8k is the same thing as 8 times k. 8k is the same thing as 8 times k. What combines 8 and k together? It's multiplication. Where was the exponent 0? It was only located for k alone. All right? So therefore, this is going to be 8 times 1. What is 8 times 1? It is going to be equal to 8. Okay? Yeah. You guys need to understand that for an expression, this is a number, this is a letter. This is 8k. All right? Okay. This is different when you have a number. Guys, this is a number, 25 to the power 0. Guys, we know that 25 is 25. 25 is a number. 25 is not 2 times 5. No, it can't be. Okay? 25 is 25. So if we say 25 to the power 0, then of course we are applying the 0 to the entire number. So what's 25 to the power 0? It is just 1. Okay? Because it is 25. It would be a different story if we said 2 times 5 to the power 0. This is something completely different. 2 times 5 to the power 0. What is 2 times 5 to the power 0? The exponent is only above the 5. So therefore we say that the answer here is 2 times. What's 5 to the power 0? It's 1. So therefore the answer is 2. So please, in your head, separate these two things, guys. 8k can be written as 8 times k. That's what 8k is. All right? 8 times. They are combined together because of multiply. Because this is a coefficient and this is a variable. This is a number. It's 25. 25 is not 2 times 5. 25 is simply 25. So this entire number raised to the power 0 should give us what? 1. But if we had something like this, 2 times 5 to the power 0, this is a different story because this is not 25. This is 2 times 5 to the power 0. Where is the exponent applied? Only to the 5. So therefore 5 to the power 0 gives us 1. What's 2 times 1? That gives us 2. So please look at these different scenarios. Scenario number 1, scenario number 2, where you have a variable and a coefficient, and scenario number 3. Okay, this is a number on its own raised to the power 0 gives us 1. This is a coefficient with a variable. This is a number with a letter. What relationship exists between the two? It's one of multiplication. Where is the 0? It's above k. So therefore the answer will be what? 8 times. In the place of k to the power 0, write 1. And then what's 8 times 1? It is 8. Okay. All right. Hope it's clear now. So far, I hope we are going okay. We wrote 3. This bracket is raised to the power 0. That becomes 1. We multiply by 2. There's the multiply by 2. Okay. Plus 256 to the power 0. 256 to the power 0. Remember, I said this is a number. So remember, the situation of a number raised to the power 0. The situation of a number raised to the power 0 will give us 1. Then for the last term, plus 8k to the power 0. The 8 is multiplied to k to the power 0. Remember, k to the power 0 is equal to what? To 1. Okay. Now we can go ahead and simplify. Okay. Does that make sense? Now we can simplify and get our answer. So we apply BODMAS. Don't forget BODMAS. Okay, because 3 times 1 times 2, we can deal with this alone. 3 times 1 times 2, what's 3 times 1? It's 3. What's 3 times 2? That is 6. Plus 1, all right? And then plus what? What's 8 times 1? Plus 8. Now, all we have now left behind after dealing with the multiplication is we now have addition on its own. 6 plus 1 plus 8 should be able to give us an answer that we can actually be proud of, and which basically makes a lot of sense. So 6 plus 1 plus 8 gives us what? 6 plus 1 plus 8 should give us a beautiful, nice answer, onga of 15. And that is basically what we were looking for. The answer 15. All thanks to who? BODMAS. BODMAS. So please guys, always first establish when you look at an expression, how many terms do you have in your expression? Because when you know how many terms you have, using BODMAS, you'll be able to see where you need to start and where you need to move, all right? And this is basic simplification that we need to master, because when you've mastered the basics of this, then basically everything else really and truly is not that painful. But it's crazy when you have grade 11s and 12s that have gaps with these basics. Then it complicates other topics that they do in grade 12 and in grade 11. And in actual fact, that's why there's so many marks that fall between the cracks, because people are not mastering or have not mastered the basics. So it makes complex things even that much more complex because the basics are not there. Okay, Tabi, so all the nerds are here today. That means you're a nerd yourself. And so welcome to Nerdship. You have signed up. Okay, receive your crown. Receive your crown. All right, here's another one. Okay, if I asked you guys how many terms are in this expression, what will you say? How many terms do you see in the expression? Let's see, comment in the comment section. How many terms do you see in the expression? Remo says 1. Thank you, Remo. Brody says 3. Chica says 1. No Pinky says 1. Welcome back, No Pinky. Familiar live spectator there. Mikey says 1. Bobby says 1. Tandos Chulu says 2. Onga says 2. Pretty says 3. Now guys, that's where I think the misunderstanding is. How many terms in the expression? Guys, there's only 1 term in the expression. Now I'm sure some of you are like, huh? Haibo, this guy is saying 1, but me, I see 3. All right, and I'm sure Pretty Kia is like, I say, me, I see 3. All right, you can see Pretty Kia 51 there in blue is saying there's definitely 3 terms, and L is saying there's 2. So how do we know how many terms there are in an expression? Guys, we need to first be mindful of the fact that if I wrote down this and I asked you how many terms are in this expression, I'm sure you guys would all tell me. How many terms do you see here? Just in this, how many terms? This is the letter A. How many terms, guys? Because I want to establish some things here. All right, so we have a Buddha temple there, Islam, 111. Very good. Okay, you guys get the point. Let's see. AB, how many terms in this expression? AB. Okay, got 111, got 1, still 1. Pretty says 2. Now do you see? LMNOP says 2. Now that's where the misconception is. Guys, all of you were happy to tell me that there's one term for this guy. All of a sudden, I write a second letter next to A, and then people are saying there are 2 terms. Guys, that's not how we establish how many terms there are, right? If you look at AB, we know that AB is the same thing as A times B. What combines A and B together? What is the glue that holds A and B together? What is the secret in those guys' marriage? They've been married for 10 years. They've been together forever. They've not separated. What is the secret in that relationship? Guys, the secret is multiply. You must multiply. Multiplication combines terms. Multiplication does not separate. All right. So if you're looking at A, B, and you say there are 2 terms, it simply means you are counting A and B. No. We that's not what we look at when we are counting terms. We look as to whether is there a plus or a minus sign that is separating the terms. Currently with A and B, this still means 1 term. AB is 1 term. Why? Because just as A is 1 term, AB is also 1 term. 1. It's 1 term, right? Because A and B are combined by multiplication. Does multiplication separate terms? No. Does multiplication separate terms? No. Multiplication combines terms. So we still say this is 1 term. This is also 1 term. I think let's spend some time here. This is important for me. So A, we all said it's 1 term. Then I said AB, we still retain that this is 1 term. Let me ask another question. X, Y, Z, P. How many terms, guys, are in this expression? Okay, so let's remember, we said AB is the same thing as A times B because multiplication combines terms. X, Y, Z, P. How many terms are in this expression? Chika, I like that. I love your comment there. I love Chika's comment. Chika, look at Chika. Addition separates terms. Multiplication marries terms. Have you ever wondered why, Chika, they usually say to people that are married, you can now multiply and replenish the earth? Multiplication and replenishing the earth means having kids. You can only legitimately have kids within a marriage, you know, because there's that union that combines those 2 people together, and no one is going to hopefully run away from that situation and be like, once they have the kid, they're like, I'm not the father, or get rid of that child. All right, because you have a sense of ownership. So yes, guys, AB. Okay, yes, very good. Addition and subtraction. So addition and subtraction separate. Addition and subtraction do what? Separate terms. Terms are separated. Divorce happens with addition and subtraction, whereas with multiplication and division, it's not only multiplication that marries terms. Multiplication and division, they actually combine terms to become 1. Okay, all right, I think now we are getting somewhere. All right. I love what people are saying in the comments, like, because it means we are getting somewhere. Even those people that keep on getting things wrong, just be patient with yourself. You'll get there. Okay, my child, just be patient with it. You will get there. Don't be too hard on yourself. It's okay. At least it's before Christmas. You are getting something, you know. Some of you don't realize that you are giving yourselves the best Christmas gift ever. You are starting to understand something maybe you did not understand as well, or you did not even care about to understand because you joined this life. That's a Christmas present to yourself. Good job on you. Okay, so XYZP, guys, is one term. You guys are 100% correct. Why do we say it's one term? We are not counting the letters here. No. We are simply checking the relationship between the variables X, Y, Z, P. Thank you to Lucilla for the heart me. So that's the same thing as X times Y times Z times P. What does multiplication do to X, Y, Z, and P? It just simply combines those terms. So there it is, guys. One term. Let's go further. No problem, no. I'm here for you for that reason. Let's go. Let's check this out. Let me ask this one. How many terms they marry each other? Yeah, multiplication and division, guys, they marry stuff. They combine things together. 3/4. How many terms in this expression? Yes, so between letters there's a hidden multiplication. Thank you so much for that clarification as well. 3/4. Thank you, guys. One term. I don't expect anyone to say anything else. It's one term. And now you are going to ask, why is it one term? Remember, the 3. This line is a division line over 4. So 3 divided by 4. Division, we said as well, what does it do? It combines terms, guys. Division also does what? Combines terms. We are getting somewhere. Check this out. How many terms in this expression? X plus 3 in brackets. How many terms? How many terms, guys? Chica, I see your answer. No. I see the sad face there. I don't know why you're having a sad face there. Nom, thank you. Once again, how many terms? One term. Why do we establish that X plus 3 is one term? Someone might be looking at this and being like, but sir, didn't you say plus separates terms? Didn't you say X, and if there's a plus sign, we are supposed to separate the terms? Aren't we counting 1, 2? All right. Well, you are right. Inside the bracket, there are how many terms, guys? There are 2 terms. Okay. But as Nom says, because, look at Nom's comment there. I'm going to pin it. Because it's in brackets. Thank you, Nom. Because what do brackets do? Brackets also combine. So we don't only have multiplication and division combining, but we also have brackets combining things even though they are separate. Brackets combine even though things are separate. All right. Brackets combine even though things are separate. So I love that. The minute we have brackets, there's one term. But guys, tell me this. How many terms in this expression? This one, just this one. How many terms in this expression? Sad boy, when you are making yourself sad, I'm sorry. Thank you, guys. You guys are beautiful. I am loving you guys. You guys are getting it. So how many terms in this expression? You guys are 100% correct. There are 2 terms. 2 terms. We don't have a bracket. We can simply count the terms that are here. X is alone. The plus sign separates these 3. So what does the plus sign do? It separates these 2. No bracket means we can count freely. 1, 2, 2 terms. How many terms in this expression, guys? X squared plus 3x minus 4. How many terms in this expression? Okay. Okay, nice. Ingathi ndizoya esikolweni ndiyokwenza i-corrections. Hello. Thank you. Guys, you guys are good. 3 terms. You guys are 100% correct. You see, there are less people that I'm correcting now in the comment section because why? Do you know why I'm correcting less people now? It's because you guys are finally understanding the concept behind how many terms there are in a given expression. This is so important, guys. You need to know how many terms there are in it. Let me see if you guys are really with this. They are not understanding. Sad boy, when you are sad, that's all. I don't understand how you can be sad, but you have what is this? You have a profile picture with 2 hands pointing to a cross, but you are here just spewing out nonsense and negativity. Okay, no, sad boy. You are the one that just joined in, and when you said initially that this live is making your head hurt because you are on holiday, you are enjoying yourself, and we are harassing you with what we are doing. Okay, sad boy, if you want to be sad somewhere else, please leave the live and be sad somewhere else, my friend. I don't want to be dealing with negativity at this point in time. X plus 3 over y squared plus 7x, guys. How many terms in the expression? Profile picture is for deco. Neat. Some of you guys are just terrible. Someone here is forward. Kalok said boy is forward because when you are not being positive, you are being very negative in this live session. All right. Now take note that if your negativity persists, I might just block you. Okay, guys, here Nopingi is saying 4. Okay, Nopingi is being deceived by the fact that, and I'm sure Nopingi is doing this. Nopingi is looking at the top and is saying x plus 3. That's 1, 2. Then he's going to the denominator and he's counting 3, 4. And no Pinky, what I want to say to you is that to say it's 4 terms is actually incorrect. Okay, let's move on. Nom, I see you said 2 terms. And I know the reason why you are saying that. It's because you're looking at this at the top and you're saying it's 1. You're looking at this at the bottom, you're saying it's 2. And that is also what? Incorrect. So all in all, how many terms do we have, guys? Some of you, majority of you said it's 1 term. Not 1 terms, 1 term. And that is 100% correct. Guys, remember, a fraction, however many terms you have in the numerator or in the denominator, a fraction will always be 1 term. Just a fraction that is there on its own is what? 1 term. Doesn't matter how many terms you have in the top, doesn't matter how many terms you have at the bottom. This is simply regarded as what? 1 term. Okay? And yes, of course, in the numerator, you are right. We do have 2 terms. In the denominator, we do have 2 terms, but we don't add those 2 terms and we say it's 4 terms. No. A fraction is simply 1 term. Okay. All right. Okay. I hope we learned a lot from that nice exercise because it's very important for me. All right. So let's come back here. Remember, I asked you how many terms in this expression. Maybe you guys can answer now. Okay. Maybe now you can answer for me. Okay. How many terms in this particular expression? Oh, do you see how quick Chica answered? Onka. Guys, I love it. Okay, all of you are making me smile. Nom, you're still missing it. Okay, still missing it. There is 1 term, guys, in this expression. 1. Okay, 1. Does that make sense, guys? 1 single term. Pretty clear. Please teach us grade 10 in January. Are you killing me here? Killing me softly. Send me an inbox message. I'll give you further details on that. 1 term, guys. Okay, it's 1 term. Why? Because the bracket, remember, everything here, okay, there's 1 term inside the bracket. The bracket in and of itself with the exponent still makes it one term. The negative sign just means that this thing is negative. So this is one term. Okay. Right. Guys, this is content that is relevant for a grade 8, 9, 10, 11, and 12 learner. It's not just 8 and 9. Because a grade 12 learner that cannot identify how many terms there are is simply running into a big, huge problem. So it's important for you guys to know how many terms there are. Just simply know how many terms there actually are from a given expression. Okay? Even if you are doing college NCV, you guys go ahead, Moss, and you do these things as well. You do the high school mathematics there. You also need to know this, okay? Just for your own sake. All right. But remember, guys, we are not here to establish how many terms there are. We are here to simplify, okay? We were here to simplify. Pretty clear. If that is the mindset that you have, then I'm very sorry for you, my girl. If it's December now and you are simply going to go ahead and forget, I'm very sorry. I have people like Tlohi there in the comment section, and the Tlohi is not lying there. Tlohi was one of my students from last year. December time, we're doing these live lessons, and Tlohi was joining in the live lessons. Term 1, beginning of the year, when he went to school to do the maths for the grade 10, 90% was the outcome for his term 1 as a grade 10 learner. You can imagine, Mosi, coming from grade 9, you're choosing grade 10 pure maths, and Rohi was able to get that resounding 90-something%. And he is the one that is saying that it's the live lessons that helped. Me, I know it's him that helped himself, but yeah, I know it was him. He did the things. Okay. All right, guys, let's come and simplify this, because our objective was to simplify this. So we've established there's one term, but before we go ahead and simplify this, what do we need to remember? Let's not forget this guy. Who? Bad maths. Brackets, exponents, division, multiplication, addition, subtraction. Brackets, exponents, division, multiplication, addition, and subtraction. So if we come here, we have a negative 2x to the power 3y squared to the power 2. Remember, according to bad maths, what do we need to start off with here? Brackets. Inside the brackets, so far, there's nothing that we can simplify. So then the next thing after brackets, what do we then have to then look at? Exponents. Which exponents? The exponent outside the bracket. It will first get priority over anything else. So we are going to then do what, guys? With the exponents, we are going to distribute using what? S meaning sign, N meaning number, L meaning the letter. Distribute the exponent inside the bracket, applying the sign, the number, the letter. Are we together, guys? So that means the negative sign is going to stay outside. It is an uninvited guest for now. People are having Christmas dinner within the house. It is very warm. The negative sign is an outside beggar wishing for the Christmas dinner inside the house, but there is surveillance cameras watching, the house to ensure that first things first, the family is safe. All right. So we are going to then apply the exponent to the sign, to the number, and to the letters. Can we do that? Yes, because there is one term. The one term inside the bracket is there, so we can apply the exponent. Remember, guys, we said we cannot apply the exponent if there's two or more terms, but because there is one term inside the bracket, we can apply the exponent to the sign, the number, and then the letters. What will that lead to? So the stranger who is hungry must stay outside for now. Let's first deal with what is inside. If we apply an even exponent to a negative sign, what sign do we get, guys? You should know this by now. When we apply a even number exponent to a negative sign, what does that sign become? Does it stay negative or does it change to positive? when we apply a even exponent to a negative sign. Thank you, Nopingi, for your response there in the comment section. Nopingi is on fire there. Chika, no, it does not change. It does not stay negative. Okay, it changes. Please, guys, even exponent. Remember, guys, even numbers 2, 4, 6, 8, 10. In fact, even 0 is an even exponent. Okay, 0 is an even number. All right, so if we apply a even exponent to this negative sign, it becomes positive. Okay, so that means the sign is taken care of. We move on, we apply the even exponent to the number. That becomes 2 to the power what? 1 times 2. Make sense? Okay, then we apply the even exponent. After applying it to the number, we apply it to the two letters. Apply the even exponent to the letter x. That becomes x to the power 3 times 2. Does that make sense? Then we apply the even exponent to the variable y. That becomes y to the power 2 times 2. Guys, I'm telling you, I am telling you, why is there a negative outside the brackets? Because the question, when we got it, has a negative outside. Guys, this is where I'm getting the questions. There, the question has negative into negative 2x to the power 3, y squared, all raised to the power 2. That is the question. The question is stated in that way. That's why there's a negative sign outside the bracket. So when we are looking at answering the question, what did I say to you? When you look at the question, there's one term, so then it means you look at BEDMAS. Okay, which means what? Brackets. So we first focus on the brackets. Then we look at what? E means the exponent. There's nothing we can do with what is inside the bracket. So then what do? We look at the exponent. Okay, because that's what BE stands for in BEDMAS, brackets, exponents. Then when we actually apply the exponent, we apply it to one of three things. First, we apply the exponent to the sign. Which sign? The sign inside the bracket. Remember, guys, we said brackets, exponents. So we are applying this exponent not anywhere else but inside the what? The bracket. Okay. Yeah, Tlohi there in the comment section has just revealed to you that negative sign just means negative 1. So hopefully you understand that too. Okay. So you apply the exponent to the sign. All right. And as I said to you, if we are applying a even exponent, if the exponent is even and you apply it to a negative sign, that negative sign simply changes to positive as long as the exponent is even. But if there was a negative being applied by a odd exponent, if the exponent was odd, not even, then the sign would remain as negative. Please, guys, understand this. If the even exponent is even, you apply it to a negative sign, the sign becomes positive. Thank you, Mkuseli, for the rose. You apply a even exponent to a negative sign, it becomes positive. But if you apply a odd exponent to a negative sign, the negative sign remains negative. This is an important rule you guys need to understand. Applying a even number exponent to a negative sign leads to a positive answer. But applying a odd number exponent to a negative sign leads to a negative answer. So that's why, for instance, this negative sign is no longer there inside the bracket, because I applied the what? The even exponent to the what? To the negative sign. I applied it to the sign. That's why I say S, you apply to the sign. S means sign. You apply the even exponent to the sign that is negative, it becomes what? Positive. Then you apply the even exponent to the what? To the number. Which number? 2. What is 2? 2 is the same thing, guys, as 2 to the power 1. So if I was to reveal what exponent is there for 2, there, the exponent is 1, guys. All right. So when I apply the exponent 2, I am saying 1 times the 2, the ghost one that you don't see. Guys, that ghost one is there, but you can't see it with your natural eye. It's like a ghost. Okay? It's like a ghost. All right? 1 times 2. Then you apply, after applying the exponent to the number, you apply the exponent to the letters of the alphabet, the variables x and y. What is the current exponent for x? It is 3. So you say 3 times 2. Then here with y, the exponent is 2. You do the same thing. You multiply this 2 with the 2 that's there. You have y to the power 2 times 2. Okay, I hope you are with me now, guys. I hope you are with me now. Right? I hope you are with me now. Negative 2 to the power 1 times 2. That gives us 2 squared, x to the power 6, y to the power 4. X to the power what? 6. Y to the power what? 4. Then finally, negative into, what's 2 squared? That is 4. X to the power 6. Y to the power 4. Then now we can finally take the negative and multiply with the 1 term that we have. So it's like saying a negative. Since brackets mean multiply, we're going down the BE. Division is not there. We move on to multiplication. Multiplication can now be applied. What's negative times this whole thing? It becomes a negative, because a negative times something that is positive gives us a negative 4x to the power 6, y to the power 4. That is the answer, and that is how we finish off that problem. And all we did was simply move down from B brackets. We first checked, is there anything we can do inside the brackets? And the answer is no. So we move down to E. Why did we remove the negative by 2? Which negative by 2? I'm going to answer that now. We move down to E. E means exponent. We apply the exponent to the what? Remember, we apply the exponent to the sign, to the number, to the letter. Now, I'm going to now show you step by step. I'm going to apply the outside exponent to the sign that is inside the bracket. What is the current sign inside the bracket? It is negative. So we are going to apply the exponent to a negative sign. And what did I say to you guys, my grade 8, 9, 10, 11, 12s that are here? I said when you apply a even exponent to a negative sign, what happens? Okay, all right, sorry guys, sorry about that. So as I said, you apply a even exponent to a negative sign. Negative sign, you apply something that is even. You take a even exponent, you apply to something that is negative. That leads to a positive outcome. This is a rule, guys. Take any negative sign, when it is applied to an exponent that is even, it leads to a positive answer. Any negative sign, if a even exponent is applied to that negative sign, it will lead to a positive answer. But take any negative sign, apply a odd exponent, it will lead to a negative answer. Okay? Odd, guys, odd numbers are like numbers like 3, 5, 7, 9, 11. I'm hoping you guys know what odd numbers are. Even numbers are like numbers like 0, 2, 4, 6, 8, 10, 12, 14, 16. So as long as the exponent is an even one, the minute you apply it to a negative sign, it leads to a positive answer. But if the exponent is odd and it is applied to a negative sign, it leads to a negative outcome. These are fundamental rules that you need to know. Even exponents applied to negative sign, odd exponents applied to negative signs. Onga is like, I have never heard of this rule. Then Onga, I want you to take a moment right now and be like, thank God I joined this live lesson. Thank God I joined this live lesson. Because you know what? Me, I'm thinking of like Santa Claus coming down my chimney. I want that iPhone. I want mom and dad to get me this and that. Guys, you don't understand. This is a gift to you. The knowledge. Why are people perishing? Why do people perish? The Bible says people perish because they lack knowledge. Knowledge. They don't know the how. They don't know something. There's something missing. Information gap. Now imagine taking an information gap and writing your final end of year exam for grade 12. Good luck. Good luck. Okay? Do you know how destructive that is? Do you know how crazy that is? Go and write an exam with information gaps. Do you know how frustrating that is? Then the marks come back. They tell you you got this mark. You cannot believe for the life of you why you got that mark. You get hurt and disappointed and you're like, I think I'm cursed. No, you are not cursed. I think maybe my parents, no. Information, knowledge. All right, please, guys. All right, I am giving you nuggets, nuggets for free. Yeah, nuggets for free. So no, I'm glad. I'm glad. I'm glad. So knowledge empowers, guys. Okay. Yeah. No wonder Scripture says the fear of the Lord is the beginning of wisdom. Wisdom begins when there's some sort of reverential fear. I've seen some of you come in here, you come to the live, you just ridicule, you say a lot of things in the comment section, you leave. Those are people that have no sense of like whatever. And then they get shocked when they get the marks. They get shocked how they perform and all of those things. All in all, yeah, whatever you get it. And please, don't just say, I'm going to get it for now. Okay, guys, Tlochi said to you guys that Tlochi is a living witness of someone that joined my life. I didn't know Tlochi from a bar of soap last year. How Tlochi was able to locate my live lessons and join them as a grade 9, a grade 10, grade 9 learner who had just finished grade 9 and then joined them so that it helped in grade 10. It's something you can ask Tlochi, but at the end of the day, the live lessons helped. So please, don't just say, I'll forget. No. Please prize the knowledge. Prize it. Keep it. Write it down. I see some of you are saying you've taken notes. That's very good. I'm happy for you. So, as I repeat, even exponent applied to a negative sign gives us positive. Does that make sense? Apply even exponent to a negative sign, positive answer. Then we are done with the what, guys? I'm repeating this thing over. The sign. Okay, so the sign is finished. Then you take the same thing, you apply the exponent to the number. Okay, we are done with the sign. We move on to the number. The next multiplied item, which is 2. 2 to the power. Remember, guys, there is a 1 that's here. And this is what I'm trying to say. There is it's like the Holy Ghost, man. It's like God. People say he does not exist, but, because they don't see, but he's there and is present. So it's like that 1 that's there. You see, that 1. It's there. Sometimes when people reveal it, then it's like, oh, there's actually a 1 there. Yes, there's a 1. The 1 has always been there. Just because you don't see it does not mean the 1 does not exist. Okay, so it's there. Then you multiply the exponent for the number base. 1 times 2 for the number. Then you are done with the what? The number. You move on to the what? The letter L, the variables. X is raised to the power 3 at the moment. So it's 3 times 2. Then Y is raised to the power 2. So it's 2 times this 2. And then you do the maths, guys. 2 to the power 2 is 4. X to the power 3 times 2 is 6. Y to the power 2 times 2 is 4. And then all in all, you get 4x to the power 6, y to the power 4. Does that make sense, guys? So with that done, you did your brackets and your exponents for BEDMAS. D is not here because we don't have any division relationship here. So we skip that. We go to M. What does M mean? M means multiply. But now what we can see is that there's this negative that is outside this bracket. So now we can actually now multiply this negative with what is in here. All right? Because multiplication says we multiply as well the what? The sign, the number, the letter. So remember, 4x to the power 6, y to the power 4 is combined. So all we do is simply multiply this negative. Remember, Tlochi said it's actually negative. There's a 1 there. It's like God, you don't see. He's there. Just because you don't see it does not mean it's not there. There's a 1 there, negative 1. You multiply negative 1 with 4. You multiply the sign first. Negative times a positive is negative. You multiply the numbers next. 1 times 4, it's 4. Then the letters remain as x to the power 6 and y to the power 4. That's it. Done. Finished. That is the answer. Okay. All right. I hope we are all now fine, sorted. I know, but that's why I was saying BEDMAS. No one can talk me out of BEDMAS when it comes to algebra and maths. BEDMAS is the way to go. Okay, as long as you know the order of how to approach things. Okay, the order. It's just there, the order. All right, let's move along. Next question. 3r squared p times 5r to the power 9p squared. 3r squared p times 5r to the power 9p squared. 3r squared p times 5r to the power 9p squared. I think you guys can actually tell me. Very good, Onga. 1 term. Onga, you are amazing. How many terms in the expression? Onga, it's actually gotten into your head. Yes, that's what you do. You first establish how many terms you have in the expression. Then you deal with each as per BEDMAS. BEDMAS. There's no brackets. Exponents we have, but for individual variables. Division, no. Multiplication, yes. We can multiply. What do we multiply? 3rp multiplied by 5r to the power 9p squared. So when we multiply, remember, we consider what? S and L. We multiply according to the sign, number, letter. So 3 and 5 are both positive. And positive times a positive obviously will give us a positive answer. We move on to the number. 3 times 5. Do you see, guys? 3 times 5. What's 3 times 5? We multiply the numbers, we get 15. Make sense? Then we move on to the letters. We have r squared, we have r to the power 9. Those are same base letters. We have p to the power 2. Let us reveal the hidden entities, the exponent that is unseen. Because that exponent that is unseen, we need to know what it is. So obviously we have r squared p to the power what? There's a hidden one there. We need to be aware of that. So if we write down our answer, we have 15, that is positive. 15 what? Now r and p, you decide. Letters of the alphabet, p, q, r. So let's start with p. P to the power 1 times p to the power 2. What does that mean? We keep the base, we add the exponents. That's 1 plus 2. Then for r squared times r to the power 9. We keep the base r, we add the exponents, 2 plus 9. Then our final answer, guys, is simply this: 15p to the power 3, r to the power 11. And that's that. Simple, straightforward, not a problem, not a sweat that we broke there. All right? Yeah. And yes, this is us trying to establish the maths basics. Thank you so much for 14.5k likes. Let's try and get it to 20k, guys. I think we are moving on very nicely and swiftly. I think 20k is very much well within our reach if we double tap all of us as one team. Thank you so much, No, for the rose. I really appreciate it. It is much appreciated. No, thank you, thank you, thank you. The first rose, I think after a few minutes have passed, really appreciate that. Thank you so much. Next problem here: 3xy times 2x squared y to the power 4 5x squared y squared. Okay. Oh, nom. Oh, nom. That comment is like comparable to a galaxy being sent in this live lesson. Thank you so much. That's actually such a beautiful comment to say there. I'm so excited for 2026 is over Donora, guys. Yeah, let's Donora them, guys. Let's Donora. Okay, I think Donora ring is the way to go next year, you know. 3xy times, okay, let's just establish what we have here. This is x and y. This is a multiplication sign. This is 2x squared y to the power 4. We have a dot. What does the dot stand for, guys? Do you still remember what the dot actually means? What does it stand for there? Do we know? Still remember? My dear beloved people. Thank you, Chica. It means times, multiply. Okay, remember I established earlier on and I said multiply can actually be articulated mathematically in 3 ways. They can either write the multiplication sign, they can write a dot, or they can write it in brackets. Those all mean multiply. So here we have it. 3xy times 2x squared y to the power 4. Dot means multiply, 5x squared y squared. So you guys have already said there is one term in the expression. So what do we do, guys, with this one term? Since it's one term in the expression, all that we need to then do is do what? What relationship exists? Multiply. Because we go down the letters. Brackets? No. Exponents? Yes, we have exponents, but they are not around brackets. They are for the individual bases. So that's not those exponents. Division? No. Multiplication? Yes. But with multiplication, what must we always consider? S, N, L. So we multiply sign, number, letter. Guys, don't ever forget this. You know, most you used to see these magical letters for movies that are very inappropriate, that young people such as yourself should be watching. But now, today, there's a glorified meaning that you attach to SNL. It's no longer the degenerated terms that we once knew that are worldly, but now they are glorified mathematical terms. That means sign, number, letter. So when we multiply, we always consider that. So we have 3xy, we have 2, we have 5. They are positive, positive, positive. And we know that a positive times another positive is obviously going to lead us to a positive answer. So a positive answer is going to be the result. And we know that a positive sign we don't have to really write down. N number, 3 times 2 times 5. You guys tell me in the comment section what's 3 times 2 times 5 so that I can take your lead and write down the number that will be the result. What's 3 times 2 times 5, my dear beloved people? Thank you. Thank you, No Pinky. Chinson, Remo. Yes, guys. 3 times 2 is 6. 6 times 5 is 30. So our number that we get after the sign is 30. It's a positive 30. We move on to the letters. What letters do we have? We have x, x squared, and x squared. So we must reveal the hidden numbers, exponents, if there are any, guys. Okay. Yes, Avamotiba. Hey, when SNL works everywhere. SNL works everywhere. Okay. Ava. Okay, x times x squared times x squared. X times x squared times x squared. We keep the base when we are multiplying because this is multiplication. X times x squared times x to the power 2. We know almost there is a 1 that is there. So what is 1 plus 2 plus 2? 1 plus 2 plus 2. 1 plus 2. Remember, when we are multiplying same bases, we keep the base, we add the exponents. Are you with me, guys? We keep the base, we add 1 plus 2 plus 2. That's for x. Then we move on to y. For y, there is also an exponent, what? 1. Those are the exponents we need to reveal, guys, so that we see them. That means keep the base for y, we add the exponents. 1 plus 4 plus 2. What is the final answer? 30x to the power 5. Y to the power 7, 8, 9, 10. No, I'm kidding, guys. It's 7. Okay. Right. Isn't that awesome? Amazing, lovely, beautiful, simple. All right. Straight to the point. So there it is, guys. SNL. Boom. Reveal of the answer. Okay. Okay, 4pt over 5xr all raised to the power 2. Let's look at this one. All right. Yes, guys, remember this is like comparable to like your grade 8 and grade 9 work. Okay, it's still really just getting into the fundamental basics. This is why I'm getting into the fundamental basics, because before I jump into the grade 11 hardcore stuff, because this is like the foundation for the grade 11s, and they got another thing coming. Okay. Okay, there. Why don't you do this one? So can you give us one that is in the comments? We do on our own. Oh, okay. Okay, let's give you this one then. Nom. Chica, you must stop saying fractions are your weakness. Yeah. Guys, hopefully these biscuits will be coming up very soon. You guys will be, I know it's Christmas. Choice assorted is the way to go. I think I've got my own little bowl of choice assorted. Let me just showcase it to you guys. Look at this, such an array of beautiful, nice, delicious, delectable stuff to be eaten. Nom nom nom, nom 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 nom. Okay, but anyways, this is the problem. Okay, let's tackle this one. it needs to be tackled. 4pt over 5xr all raised to the power 2. Okay, I think now I'm just going to give you do it. Then maybe if you want, you can guest request and you can come in and you can answer and you can walk me through. Lo December sicabanga imets. No, that's fine. You could, it's okay. It's okay. We are tabangaring the maths. Let us tabanga it, please. Let's tabanga it. Thank you, Tlochi. Tlochi is doing a very good job there, you know, for a first timer. Presh, this is for all grades. This is just exponents. We are unpacking the basics. Grade 12, I'll see you. I think I'll see you guys at 8 p.m. earlier today. I'll see you at 8 p.m. Grade 12, I'll see you at 8 p.m. We'll continue sequence and series. We'll see where it takes us, where we can be taken. Okay. Onka, this is the foundation for grade 11. I'm laying a foundation here for the grade 11s. I just don't want to go in too deep. I want to go start with the rules first, get light. This is the foundation for grade 11s, all right? Yeah, so we'll get there with the exponents and surds and all of that stuff that you guys, I know you guys are waiting for me to do but I'm still trying to, yeah. Oh, shame, man, my data switches off at 7. I'm sorry about that. I didn't know, Tlochi. Okay, Tlochi, bye. This looks hard. Can you do it for us? I'm sorry. Saying Yakvuma, it's my first time. But I understand. Oh, first time, okay, no, that's fine. Tlochi, bye. I'm so sorry about your data switching off issues. Yeah, we must pray for eternal data, guys. Data that does not ever switch off. We'll go deeper, Matabashe. Once I am able to establish that the basics are fine, then we'll go deeper. We'll go deeper. Deeper is deeper is not deeper when basics are basic. Deeper is actually weak. It's not even deep. The only reason why deep is because basics are not understood well. Okay. Thank you. There we go. Tlochit is helping us there. Remember how many terms, guys? We need to always go back to that. How many terms do we have there? Okay, I think we've forgotten. Guys, how many terms? There's only one term. So if there's one term, remember, guys, that there's an exponent that's outside. What does that mean? The relationship between 4pt and 5xr is one of division. All right, there's no plus sign, there's no minus sign, and because there's no plus sign or minus sign in between the terms in the numerator and the denominator, we can simply take the exponent 2 and distribute it for what? The sign, the number, the letter. Okay, does that make sense, guys? I hope it makes sense. Okay, I hope it makes sense. Okay, I hope it makes sense. Hey, pretty zondi, that's an interesting one. Sometimes not all situations are the same. Pretty, I have had students that didn't do well in grade 9 myself that I used to teach. They didn't do well in grade 9, and because of that they had to not choose pure maths. I actually have a student that actually ended up changing from maths literacy. Hey, I have funny stories, I'll tell you this. I once had a student. This particular student was doing matric this year, but this particular student did not basically get into maths because of their performance, which they thought was not up to standard. They ended up doing maths lit for term 1, but then they felt like maths lit was too weak for them, and then they asked to change from maths lit to pure maths. Very, very, very unique situation. I fought tooth and nail. We as teachers, we fight against learners and parents from doing pure maths if we can see there's no potential, to be honest, you know. But that particular learner came with the parent, committed to actually doing pure maths and was like, I'm going to change from maths lit. I want to do pure maths. Term 1, term 2, he did pure maths. And I tell you this, that kid was actually one of my top students in class for mathematics. He was getting your low 90s to high 90s given good occasions, so yeah, your particular child, I think you are going to have to actually, maybe you can DM me, please. That particular parent can DM me, send me a message, Pretty Zondi. Maybe we can talk on the side. I would be happy to even maybe engage in conversation with your son or your daughter, so that we can establish, what's what, yeah. At the end of the day, kids are allowed to choose, and I think that's important. You must understand that right, that you have to choose, but then you must support your child the minute they choose that particular subject, because maths needs a learner to really be a bit more committed and a bit more serious, because to get maths marks that are mediocre is not good enough. You must really aim for the best. Okay, so guys, like I was saying here, we have 4pt over 5xr. It's all raised to the power 2. So 4pt, remember guys, 4pt is one term, okay? The relationship between 4p and t is one of multiplication. All over 5xr, the relationship between 5x and r is multiplication. So the relationship between these is one of division. There's no plus sign in between, there's no minus sign in between. So because of that, because we only have multiplication and division, remember guys, with multiplication and division, we can apply S and L. For the what? For the exponent. Remember, we first look at brackets. Is there a bracket? Yes. Can we do anything with simplifying what's inside the bracket? No. Then we move on to E. E means exponent. Okay? Okay? Does that make sense? Yeah. All right. Then exponents there. We have the exponent 2. So that means we can apply the exponent to the what? To the bracket, because the relationship that exists between my bases is multiply and divide. So if it's multiply and divide, then I can simply apply my S and L. Okay. Okay. So let's do that. Apply exponents to the sign, which is obviously positive, the numbers. So let's start with the numerator and then go to the denominator. So if I apply the exponent to the numerator, that means we have 4 to the power 1 times 2, then p to the power 1 times 2, then t to the power 1 times 2. That is the numerator. We go to the denominator, we have 5 to the power 1 times 2, x to the power 1 times 2, r to the power 1 times 2. That is the exponent being applied to each individual base, because the relationship is one of multiply and divide. S and L is easily applied in the sense that our exponent is applied to the sign, the numbers, and all the letters that are in the available expression. Then when we simplify, what do we get? In the numerator, we get 4 squared, p squared, t squared, 5 squared, x squared, and r squared. Then finally, what is 4 squared, guys? It is 16. P squared, t squared, over what is 5 squared? 25. X squared, r squared. Finally, that is the answer. Okay. All right. Okay. All right. That wasn't bad, was it? Not bad at all. Okay. So all in all, really and truly, that is it. Nothing too hectic or shabby or, you know, or too much. All right, let's see if you guys can do this one. You were trying to simplify the answer. No, the answer cannot be simplified any further. That is as simple as you can get. Okay, so don't pressurize. We have a square bracket that has the exponent 2. Then inside we have x to the power 3. Okay, then inside we have 3xy all raised to the power 2. Okay. Oh, Dinilicious, I did my metric in 2019. I want to rewrite. Would you advise me to write June or November? If you can write in November, your girl Dinilicious, then it will give you sufficient time to prepare. I don't know how well prepared you feel, because if May, June is, you feel like you can prepare adequately for May, June, seeing as though you last did metric in 2019, because remember, you're going to have to actually, I hope you're actually joining some sort of an academy so that you can actually, like, you know, deal with the content for your respective subjects that you want to rewrite, you know. Yeah, are you actually going to be signed up in a specific school, or are you signed up in a specific academy so that you can actually prep yourself for all the subjects that you are going to be rewriting? That's my question to you. You can DM me on the side and we can talk about this further if you want. So x to the power 3 brackets 3xy, the whole thing squared, with the whole thing raised to the power 2. Okay, so once again, we first establish how many terms. Obviously you can see it's 1, because even though there's this big bracket which is housing everyone, it's housing this bracket, the small one, and it's housing the x to the power 3. The relationship between x to the power 3 and this bracket is one of multiplication. So in all, this is just one term. All right, and depending on who's doing the problem, there's really various ways that you can answer this question. There's no one single way of answering this question. It just depends on what you see, you know, and what you think is best that ought to be done. Okay, yeah, so I think, yeah, depending on who's doing the problem, right, someone can see this base and that base, can apply the exponent to this base, and then apply the exponent to this particular exponent, and then remove this bracket by doing that, and then multiply these two after that. Or you can deal with these two inside the bracket, then apply the exponent after. It's really up to you. Both methods will work. You can solve the problem, and if there's someone who feels they can do it, please, you can guest request. I will accept your request, and then you can lead us through. You can walk us through how you went about doing the problem. Why we learning maths in December? You're trying to give me PTSD. No, Meadowville. I am not trying to give you PTSD. You yourself, by entering into this live, are exposing yourself to being affected with PTSD. So let me advise you very quickly. You can just flick. You just flick, you scroll through to the next live, you know, and then that way you will sort out your PTSD problems. Okay, you have that choice. So please don't stress yourself and get yourself gung-ho with PTSD. Just scroll through, my friend. Scroll through. No, don't apologize. You are being honest about how you feel. But I want to also help you out with your situation. You can scroll through so that your PTSD is limited. Yeah. Oh man, that's funny. Onga is like a good person to go to war with, you know. Onga would like defend you like crazy. Okay, Okay, so is there anyone who would like to request, and then I can invite them up? They can walk us through how they did the problem. You are more than welcome. Don't be scared. Be courageous. Come through. Mr. Virtue's like, no. Mr. Virtue, maybe there's someone. Give people a chance, will you? Maybe Mpepetua is Mpepetua. I see Mpepetua there. And Boni. No, Mr. Virtue, that does. This is where I just simply don't. Mr. Virtue is like, increase the difficulty, guys. You can go and find problems and increase the difficulty for yourself. Me, I'm trying to establish basics so that after people have the basics sorted, then it's very easy. Okay, Mr. Virtue, chill, calm down. Don't be too virtuous here in the live session, will you? X to the power 3 in brackets 3xy all raised to the power 2, then the brackets to the power 2. Hey chica, look at these people. I'm scared. What if my answer is wrong and I embarrass myself in front of 77 people? You guys are 100. You guys are funny. Okay, so one of the ways in which you can attempt this problem, guys, as I said, okay, bed mass, ne? Brackets. So there's the small bracket, there's the big bracket. So if you are going to say, let's apply big bracket, okay, and we're going to confirm your answer. Nopingi got the answer 9x to the power 7, y to the power 4. We're going to confirm it now. So if you apply brackets exponent, this is one way of doing it. X to the power, you apply the exponent to this variable, it's 3 times 2. Okay, then you apply the exponent to this bracket, it becomes 3xy to the power 2 times 2. The bracket has been removed. You applied the exponent to this base and to this bracket, all of it. Exponent 2, x to the power 3 times 2. Exponent 2 applied to the bracket, 2 times 2. Then you get x to the power 6. Remember now, you have 3xy to the power 4, right? Now this 4 you can apply to this bracket. So x to the power 6 is just going to have to wait for a little while, whilst the exponent 4 takes care of what is inside this smaller nyana bracket. So we have what? 3 to the power 1 times 4, x to the power 1 times 4, y to the power 1 times 4. Then x to the power 6, remember what's 3 to the power 4? 3 to the power 1 times 4 is 3 to the power 4. X to the power 4, y to the power 4. Make sense, guys? Yeah. Then from here we are going to say x to the power 6 multiplied by that. Remember, when you multiply this with that, remember brackets mean multiply. So we're going to multiply sign, number, letter. The positive times a positive gives us a positive answer. That is the sign. Then the number 1 times 3 to the power 4. Remember, 3 to the power 4, guys, is 81. Okay, 81. That's 3 to the power 4. 3 to the power 4 is like 3 times 3, which is 9, times 3, which is 27, times 3, which is 81. Then you move on to the letter. X to the power 6 times x to the power 4. That's like 6 plus 4. Bases are the same. You multiply, you keep the base, you add the exponent. So it's x to the power 6 plus 4. Then it's y to the power what? There's only one y, which is y to the power 4. So our final answer is 81x to the power 10, y to the power 4. That is the answer. In the comment section, Remo had gotten the answer earlier on, which is 81x to the power 10 y to the power 4. So good job, Remo. A round of a crazy applause to you for actually getting that answer. That's one way of doing this question, guys. Okay, one way of doing this question. Brackets, as I said to you. Then we have this exponent, which we must apply inside the bracket. So that's x to the power 3 times 2. Then you have 3xy, which is in brackets, but it's raised to the power 2. So you can multiply this 2 and that 2 to get 2 times 2, which gives you what? 4. Then you must distribute this 4 to the sign, the numbers, and the letter by multiplication, which is why we have 3 to the power 1 times 4, x to the power 1 times 4, y to the power 1 times 4, which gives you 3 to the power 4, x to the power 4, and y to the power 4. Now you have a relationship of multiplication. The bases here are the same. You multiply using S and L. So you first multiply the signs. This is a positive times a positive, which gives us a positive sign. So that's why we have a positive 80. But remember, why 81? 1, which is a coefficient that we don't see here, times 3 to the power 4, which is 81. 1 times 81 is 81. There it is. So that's the number taken care of. Then we move on to the letter. X to the power 6 times, remember brackets means multiply, x to the power 6 times x to the power 4. Bases are the same. What do we do to the exponents? We add them. 6 plus 4, which gives us 10. Then y simply is alone as a variable with its own unique exponent, and we write it next to the x. Okay, so that's basically how we would go about doing that problem. So I said that's one way of doing that problem, but another way that we could approach the very same problem, guys, okay, which is no different. We still get the same answer. I just want you to see that, guys, sometimes with problems there's no single way, there is many ways. So if you look at the problem again, right, let's forget about the bracket, the exponent. Let's deal with what's inside. So let's see if we deal with what is inside. For now, we have x to the power 3, okay? Then we have 3xy raised to the power 2. Let's apply this exponent to this bracket. What do we get? We get 3 to the power 1 times 2, x to the power 1 times 2, and y to the power 1 times 2. Okay, for the smaller nyana bracket. That will then lead us to what? X to the power 3. Remember, this x to the power 3 was there already. The bracket, 3 to the power 1 times 2, that gives us 3 squared. X to the power 1 times 2, that gives us x squared. Y to the power 1 times 2, that gives us y squared. Then, of course, we have that big bracket, which is squared there. Then let's continue dealing with what is inside, because we can. X to the power 3. 3 squared is 9. X squared, y squared, all raised to the power 2. Now let's multiply what's inside and take care of it. When we multiply what's inside, we apply S and L. Remember, guys, when we multiply, we apply S and L. So we multiply the what? The sign. Positive times a positive, that will give us a positive answer. Then we move on to the number. 1, which is there, which we cannot see, times 9 gives us 9. We get the number. Then we finish off with the letter. X to the power 3, the bracket means multiply. X to the power 3 times x squared. Remember, that's x to the power 3 plus 2. Then y squared. Y squared is simply there on its own because it has no companion y. There's no y that has another exponent. Then what do we get inside the bracket? 9x to the power 5, y to the power 2, all raised to the power 2. Now we can deal with applying the exponent, because what's inside the bracket has been resolved. B has been taken care of. Now we can attend to the exponent. Take the exponent, distribute it to the single term inside the bracket. When we do it, we apply S and L. 9 is already positive. We apply the exponent of 2 to the 9 that is positive. That leads to a positive answer. So our sign is positive. We apply the exponent to the 9. We say 9 to the power 1 times 2. Then the x to the power 5 times 2. Then the y to the power 2 times 2. What is our final answer, guys? Without the bracket, 9 to the power 2, x to the power 10, y to the power 4, which is 81x to the power 10, y to the power 4. We still got the same answer, and I think for our reward, we deserve a cookie. Okay, no, that's fine. As I said, many different ways. One of my students who also met me through this platform, who managed to get 94% for his or for her grade 11 end of year exams, usually always says to me when they WhatsApp me, they say that there's many ways to kill a cat. So there's many methods, there's many ways to actually do certain things. So definitely this method, if it works best for you, by all means utilize it. It should help. If they say to you, simplify and use positive exponents, let's say they give you a problem like this. What is the answer, guys? A to the power negative 12. Simplify, write all answers with positive exponents. A to the power negative 12 is equal to what? A to the power negative 12 is equal to Vamotiba, I see you there in the comment section. I see your answer. What does everybody else have to say? Ava is saying 1 over a to the power 12. Do we agree? Do we disagree? Do we have maybe an alternative option, alternative way? Do we see it differently? Okay, Umpegi 172 is saying yes, indeed. Okay, yes, guys. Remember, what did we say about negative exponents? Remember, guys, here we don't see it, but there is a 1 that we don't see. It's there, that 1. This 1, it gets left behind in the numerator. This coefficient 1, the one that is unseen, it gets left behind in the numerator. The a changes position. From the numerator, it goes to the denominator. Because it moves from the numerator to the denominator, its exponent changes from negative to what? To positive. That is the answer. So you guys are 100%. The answer is 1 over a to the power 12. Let's move. Come on, help me out. I'm gonna get the answers from you now. Me, I'm sick and tired of solving. 1 over x to the power negative 9 is equal to what, guys? Whenever you think of Christmas, guys, ooh. Okay, 1 over x to the power negative 9. We are on 9.1k likes, guys. Let's continue double tapping, especially those who are have been tapping very nicely. Thank you so much for the likes. I really appreciate it. Let's get to 20k. I think 20k is coming up very soon. 1 over x to the power negative 9. Head x 16 head chronicle says x to the power of 9. Remo says 1 x to the power 9. Umpegi says x to the power 9. Neo says, is it not x to the power 9? Do you want to change that question into a statement, Neo? Instead of asking, state. Confidence is laced in statements. Nom, x to the power 9. Okay, very true. 1 is in the numerator. X changes position. What happens to x? He joins the 1 in the numerator. What happens to the exponent as he joins 1 in the numerator? It changes from negative to what? To positive. So yes, indeed, our answer is 1 over x to the power 9, or we can say x to the power 9. These are the same thing, guys. The 1 is there. As I said, it's like God. He's there, but he's never seen. And people, just because he's never seen, they think he's not there. Anyways, 3. Can you explain why it goes to the top with 1? Because that is the definition or the rule, chica. Okay? There's a law or a definition that says when a base is raised to a negative exponent, this is a definition for exponents that you need to know. Whenever a base is raised to a negative exponent, all right, what you need to understand is that that particular base has a numerical coefficient that is 1. So, in order to express this, we do the following. The numerical coefficient 1 gets left behind because it is not raised to the negative exponent. 1 is alone there. It's not raised to a negative exponent. The only base that has a negative exponent to it is the base a. So that base that has a negative exponent has to change its position. What does it have to do? It must change its position in order to have a positive exponent. So how do we change its position? It moves from that numerator. It goes where? It goes to the denominator. And what happens there in the denominator? The exponent sign changes from negative to positive. So therefore the answer is 1 over a to the power n. This is an exponential definition or rule that you need to know as a learner. Are we together? So whenever you experience or have a negative exponent, you see in this case now, this base is not in the numerator, but now it's in the denominator. So what happens? The base will change its position from the denominator to the what? To the numerator. And then what happens? The exponent sign changes from negative to what? To positive. So we have 1x to the power 9, which is x to the power 9. Are we together now? So the exponent affects the particular base that it is raised to. Nothing else. Okay? So that's why, for instance, here, the 1 stayed. It remained unaffected. That's why the a changed its position. Here, the x is affected. So it basically changes its position. Drizzy 2012, bro, it's holiday. Bro, it's holiday. It's holiday, it's holiday, it's holiday. But you know what? Our minds are not resting, my friend. Our minds are not resting. The maths is not resting. So wake up, Drizzy. Number 3. Here's another one. 5x to the power negative 3. Come on, guys. What about this one? 5x to the power negative 3. Simplify and write in positive exponents. 5x to the power negative 3 is equal to... Let's go. Nom nom nom. Nom nom nom, you've been around, that's for sure. Nom has been like around. I acknowledge you, all these people that have been here for hours. Yeah. Oh, Chica, you're a rock star. Yes, guys. So 5 as you guys have indicated, is unaffected. He remains in the numerator. 5 remains unaffected. Who is affected by the negative exponent? It is base x. So who changes position? X changes position. All right. He can see that the mindset is too negative. So what does base x do? He changes position. He no longer sits at the back of the class. He goes and sits at the front of the class. Then what happens? His exponent, his mindset changes from negative to what? To positive. Okay. All right. No. That's fine. That's fine. As long, what's important here is being able to get the answer right, even if you don't comment. It's okay. All right. I understand, chica. So 5 over x to the power 3. Okay. I hope we are good here. We are all good. We are all getting somewhere. Come on, let's go. 5 over x to the power negative 3 for a red label lemon cream. Woo! All right, 5 over x to the power negative 3. Yeah, guys, choice assorted. Like Christmas without choice assorted is not Christmas. So if you don't have choice assorted in your home, guys, you need to make a plan. Mommy needs to make a plan. My fear is that they might be sold out in those stores by now because everybody is probably getting them. Sipongoni, 5x to the power 3, Chica, 5x to the power 3 with a question mark. Chica, change that question mark to a statement. Confidence means, please guys, confidence means we don't put question marks. These question marks are dangerous. I don't have choices sorted. Sorry, Chica. Don't worry, Wena, don't worry. I have choices sorted for you, okay? I have it for you. 5 over x to the power negative 3. Yes, Onka, thank you. 5x to the power 3. X to the power negative 3 joins the coefficient 5 raised to the power positive 3. Mindset changes the minute we shift the position in the classroom. Guys, please change your position in the classroom. Stop sitting with those kids that make too much noise there in the middle and at the back. Start sitting in the front. Take your position of dominance and start being someone who's actually quite a little bit more devoted in your academics so that things can really start materializing. Okay, number 5. X to the power negative 3 over 5. Let's go. And I sit in the front. Very good. X to the power negative 3 over 5. Let's go. Next. Sipo. Yeah, Sipo is on fire there with his tiger there. With his eye of a tiger there. Ava, be very careful. Okay. Guys, remember, we want to write this as a positive exponent. Who's at the top at the moment? There's that one. Please, guys. You see, God forever. God is on the throne, guys. So God on the throne needs to always be revealed. God on the throne at the top needs to be revealed. So what happens? X to the power negative 3 leaves the side of this coefficient. X becomes 5x to the power 3 next to 5. But then remember, in the numerator, God is revealed. In other words, on the throne, God is revealed. Doesn't matter so much in the denominator, guys. We don't want to see, the thing is, please, we don't want to see him there at the bottom. We don't have to see him at the bottom, but at the top, we always have to, guys. Okay. Yeah, we all know about one, but we keep forgetting about him. Ish, hey, isn't that a typical situation that we find ourselves in? Yeah, we tend to forget about him a lot. So please, guys, I love that, Chica. Thank you for that comment. That's a very valuable comment. Yeah. So please, you see, you leave x to the power negative 3. Obviously, changes position. The x joins 5 multiplied with the 5. X to the power, not negative 3 now, but positive. But then at the top, please, guys, you leave the 1 needs to be there. God on the throne is always revealed. Please, guys, forever, His Majesty. 6. P to the power 4 over Q to the power negative 3. Refer, it's for all grades. All people that are doing pure maths, doesn't matter what grade you are in, this is for you. These are nice basics for any learner in any grade. Okay. If these basics are basic, then it means you are good. But if they are not basic and you are struggling with the basics, then I've seen matriculants in the comment section. People who are going to matric next year, I've seen them comment nonsense in the comment section with these basics. So just seems like basics are not basics. You know what I mean? Okay. Remember, our goal is to have positive exponents. Our goal is to have what? Positive exponents. So P to the power 4 is fine at the top. Who is going to change position because he has a negative exponent? It's Q. So what happens to Q? Q joins P. The exponent that was negative changes to positive. And typically, there would be a 1 left behind in the denominator. But you know what, guys? In the denominator, it doesn't really matter that we show the 1 in the denominator. It matters that we show the 1 in the numerator because high and seated up on the throne, He is revealed. But yeah, we know, he tramples the enemy in His feet. You see, so we don't have to reveal there in the denominator, but we reveal in the numerator because high and seated up in the throne we reveal, but we don't reveal in the denominator. So the answer is P to the power 4 Q to the power 3. All right, does that make sense, guys? I hope it makes sense and I hope it's clear, right? Clear. It must be clear for all of us, guys. We need to be getting to a place where it's just clear. We don't have misconceptions. We understand it like so well, and it's clear. Negative exponents can't be our downfall when it comes to the mathematics. Okay. Yeah, the maths must maths, my friend. The maths must maths, and the gifts must gift as well. Okay, x to the power 3 to the y to the power negative 4. No, don't worry. The gifts are gifting, don't worry. Okay, x to the power 3 times y to the power negative 4. Okay, I see there, Sharon. I see you there, Sharon. Thank you, Sipo. I see you there, Pila. I see you there, Pila. You are giving life there. Sipo, you are definitely a gift, as your name so suggests. Sharon, you are definitely sharing out the good answers. Thank you. Okay. So I think most of us are getting it, right? Why? I must leave you, my friend. I'm sorry. I must leave you there in the numerator and go where? To the denominator, where my mindset can be positive. Sometimes we need to leave certain associations and friendships so that we can actually start cultivating a positive mindset. Okay, I usually think of exponent as a mindset in a sense sometimes, I doesn't want to comment because your settings say, no problem, nom. I know for sure that you are writing the right answers. For you to even take the time and comment means you are writing the right answers. Sunny Bonani, Dumelang, Absheni, hello. Hello, Sekhamit, I see you there. Welcome to my show. The maths is a game show. Alright, so x to the power 3 over y to the power 4 is definitely our answer for that particular question. Let's move on next. Brenda, all grades, all grades, all grades. We are establishing basics here. We are getting basics established for my people here. All grades, all people. Okay, even though my grade 12s, I'm going to see them for sequence and series. I think grade 12s will see each other at 9, guys, because these basics, they are really getting to me very nicely. Okay, then simplify further, will you? Okay, because remember, those are numbers. Simplify, 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 simplify further. Give me the answer. Okay, because yes, remember, we are obviously changing so that it's negative, positive, positive, but then at the end of the day, we want the answer, right? Okay, be very careful there, Chica. We don't want to be writing things that will make you run away yourself. Thank you, Secha Meti, for the love you. I love you so much too. I love you so much too. You mean 8. You better mean 8. Gone are the days when people say 4 times 2 is 6, eh? 4 plus 2 is 6, yes, but 4 times 2 is not 6. Be very careful. So yes, guys, as you've said, 2 goes and joins. What? Goes and joins. Okay, 4 times 2 to the power positive 1, but we know that 4 times 2 is 8, guys. Okay, we simplify as far as possible, and that is basically simplification. Thank you so much, Sekhamiti, for you. Awesome, you're awesome too. Your choice assorted is messing with my brain, so sorry. Excuse, man. I'm sorry about that. Where to go? You're blaming me for your errors, eh? How nice. I'll take it. It's fine. Okay, let's go. 4 times 2 to the power negative 1. What about this one? 4 times 2 to the power negative 1. What do we do here? 4 times 2 to the power negative 1. Sipomguni. Getting straight to the answer, I see. Okay. Yeah, final answer is 2, but initially the simplification before we get to the answer, is it a must to simplify if we're focusing on exponents? Yes, definitely. Yes, definitely it is, because ultimately we want the final answer. We want to show the step that shows that we understand the application of the definition. Then ultimately we want to write down the answer because we've been doing maths beyond exponents. That means we know what 4 divided by 2 actually is. Do you know what I mean? So it's a holistic application of our mathematics knowledge. Does that make sense? So yes, 4 over 2 to the power 1. All right, but obviously that's 4 divided by 2, which is 2. Okay, yeah, we need to show our mathematical prowess. All right, 5 to the power negative 3x. Sekhametse, I see you, Pila. Yes, so initially x over 5 to the power 3. Make sense? I leave you, I go to the denominator. Then I simplify yourself. What's 5 to the power 3? Very true. X2, x over 125. So well understood. Well understood. Norman Chica, you guys, you need to leave that you need to leave these things now. Okay? Right, x over 1 over x over 125. We'll get it next time. Okay, next. 1 over 5p all raised to the power negative 2. 1 over 5p all raised to the power negative 2. Hey, Sipomguni, I see you there in the comment section. Sekhamete, I see you there. Okay. Okay, we'll move position. The entire thing, 5p, the whole thing moves to the numerator because it's 5p inside the bracket. The whole thing moves to the numerator and it becomes positive. Then after that, what do? We apply the exponent to the sign number letter. So it's 1 times, we have 5 squared p squared. Remember, it's 1 times 2, which is 2, p to the power 1 times 2, which is 2. So I'm getting straight to the answer there. 1 times 5 squared p squared, which gives me what ultimately? 1 times 5 squared, that is 25. 25 what? 25 p squared. So ultimately that is my answer. And it's really just that straightforward, guys. Nothing much, nothing to it. Next, x to the power negative 3, y to the power negative 2. Square the 5 as well. Yes. Yeah, because remember, when you apply the exponent, this is one term inside the bracket. So you square the sign, square the number, square the letter. In other words, 1 times 2 is 2. 1 times 2 for p is also 2. Then you ultimately are able to get to the answer. Okay. Okay. Sipomgoni, I see you there. What if his phone switched off? You guys are funny. Nah, I had to just make sure I take care of some things here. All right, x to the power negative 3. Have we established what the answer is here? X to the power negative 3 over y to the power negative 2. Ah, you are funny, chica. You are funny. Full of jokes, I see. Okay. Thank you so much, Sekhamid. Really appreciate that. You awesomes. So, guys, x to the power negative 3. Obviously, he's changing positions. He's changing positions. So, they are changing position. One is going to the other person's place, and the other one is going to the other person's place. Do you see that? X to the power negative 3, he goes to the denominator and he gets a positive exponent. Y to the power negative 2 has a negative exponent here, so he will change his position and go to the numerator so that his exponent becomes positive. Remember, guys, that the goal at the end of the day is to ensure that we have what? Positive exponents, okay? And the definition is still applying even though we have a situation where the exponents are respectively different, okay? So, like I said, x is raised to a negative exponent. Change position, numerator to denominator. He changes the sign. Y to the power negative 2 has a negative exponent in the denominator, so he moves to the numerator. Exponent becomes positive. Okay. Let's go. 2xy to the power negative 2 over x to the power negative 3. Left cake codes, that's funny. I finished undergrad, have a job in tech, and I'm solving these questions with you because math is so fun. Oh man, that's cute. I think that's the cutest comment I've received the whole entire day. My goodness. Yeah. Okay, guys, there's someone who's a working professional there who's has a job in tech, finished his undergrad. And that's amazing, man. Thanks for that comment. Definitely light-hearted, sweet, and very well received. I assure you of that. Thank you so much. Sharon, x over 3, very true. X to the power 3 over 2xy to the power 2. So initially, that's exactly what you do. Then you apply the other laws that you have learned so that you can actually have it simplified. So that definition is applied, but then after that you go on further, okay? Go on further and simplify it so that it is completely simplified, if that makes sense, okay? Yeah, so I love the initial though, and I agree. X to the power 3 in the numerator, because he changes position from the denominator to the numerator. Then also 2xy, he changes position and adopts a positive exponent. But we are not done, right? We are not done, because we can still simplify further. And if we can simplify further, then we do that. So in the numerator of x to the power 3, that's fine. But in the denominator, we have a bracket exponent. Remember, BE. Bracket exponent. The exponent, how many terms inside the bracket? 1. So we can then distribute the exponent applying E for S, N, L. Exponent applied to the sign, applied to the number, applied to the letters. So basically we have x to the power 3 in the numerator, in the denominator, 2 squared, x squared, y squared. You see, now I'm getting straight to business, guys, because I know you all know that the exponent 1 gets multiplied to 2, but I'm getting straight to business. You all know that the exponent 1 gets multiplied to 2, getting straight to business. The exponent 1 there gets multiplied to 2, straight to business. Okay, apply the exponent to the sign, to the number, then to the letters. Then x, numerator, denominator. Remember, bases are the same. Now we are dividing. When we are dividing, remember with BEDMAS, brackets, exponents, division. Still with division, we apply what? Sign, number, letter. We divide the sign. Positive divided by a positive is positive. The number 1 divided by 4, that's still 1 over 4. So the 4 is still in the denominator. The letter x cubed divided by x squared. When the bases are the same, what do we do, guys? We subtract the exponents. So x is going to be taken care of in the numerator, but 4y squared is left in the denominator. What's 3 minus 2? X over what? 4y squared. Thank you, Sekhamit. You got it 100% correct. Okay, this is like us saying we take the x, it changes, the base x squared changes position, then the exponent changes to negative. 3 minus 2, that's 1. Okay, and remember that 1, obviously we know it's there even though we do not see it. So our final answer is x over 4y squared. So guys, please, where there is an opportunity to continue further in our steps, we continue further. Are we together? All right, we don't leave our answer mid-air, right? For instance, if we left the answer, thank you so much, Sekhamit, for all the 10 you awesomes. Thank you so much. I really appreciate it. The support is very much appreciated. So if we leave the answer at this step, we are not done, and we wouldn't get all the simplification marks that we ought to get. Remember, what we've done here is simply apply the definition or the law for exponents, for negative exponents. But continuing further, we actually need to then continue further and apply the rest of what we know we ought to do. Okay, yeah. And BEDMAS is still working here. Brackets, remember brackets, exponents. Okay, variable exponent, it's a negative, so we know what we do with negative exponents because of the law. That's the first step. Still, we have brackets, exponents, so we continue then, apply the law for exponents. That means we distribute the exponent to the sign, the number, and the letter. After doing so, after B, E then follows D, division. We divide, and when we divide, we apply sign, number, letter. Divide the sign, divide the number, divide the letter. When we divide the letters, we can see here we have the what? The same variable x. Okay, x to the power 3 divided by x to the power 2. So therefore, when bases are the same and we are dividing, what do we do to the exponents? We subtract if the variables are the same. But remember, 4 stays in the denominator because it has no same base. Y squared stays in the denominator because it has no same base. But x to the power 3 and x to the power 2, they have the same base. And when we are dividing same bases, we keep the base there in the numerator and we subtract the exponents. Then we get our final answer. Okay, right? So I hope you guys are, yeah, man, I really hope it's clicking with you guys. Like I really hope there's something happening, you know, there's some churning movements that are happening in your mindset and you're like beginning to see, oh, okay, not too shabby. I really hope so. Okay. Okay, then Negative 2x to the power negative 2y to the power negative 3, all raised to the power 3. Now that's one for the books. Once again, how many terms? One. Exponent on the outside, definitely. So that means b brackets exponents. With the exponent, we apply what? S and L. One term inside the bracket. So we apply the odd exponent to the what? To the sign, the number, the letter. And really and truly, that's it with this particular problem, because there's nothing else that there is. So an odd exponent to a negative sign. What does an odd exponent do to a negative sign? Now I need to see if you guys were listening earlier on. Odd exponent applied to a negative sign leads to a what, guys? What kind of sign will I expect to get? The odd exponent applied to a negative sign. Thank you, Safami. Negative. Okay. Then apply the odd exponent to the number. Now apply the odd exponent to the number. So the odd exponent to the number means we get 2 to the power 1 times 3, which is 3. Okay, be careful there, Sipo. Be careful, Sipo. Be careful. The exponent, you did not apply it to the number. Okay, you forgot to do that. You applied the exponent everywhere else but the number. Okay, and that is why I emphasize this thing, that when you apply the exponent outside the bracket, you apply it to the sign, the number, and the letter. Okay, I think Sharon in my comment section is fighting you very hard. Okay, so negative 2 to the power 3, x to the power, remember, negative 2 for the variable, now the letter, negative 2 times 3, negative 6. Remember, a negative times a positive is a negative, 2 times 3 is 6. Then y to the power negative 3 times 3. Negative times a positive, negative. 3 times 3, 9. Final answer. Minus 8 x to the power negative 6, y to the power negative 9. Now you think you are done, but you are not, because the exponents are not negative, are not positive. So how do we get them to be positive? Negative 8 remains in the numerator. Then who goes down there? X and y. What are the exponents? 6, that is positive, y, that is 9. So that is your final answer. Negative 8 over x to the power 6, y to the power 9. Oh, Sharon, it's because of my restrictions. I think there's certain things that are basically limiting you from commenting because of the restrictions. But look at this. Sekhamit is commenting nicely. I don't know why. It might be that those are flagged, but yeah, that's the answer, guys. There it is. That is it. There it is. Okay. Okay, here's one for you guys. You guys can do this one on your own. I'm not gonna do it. 7a to the power negative 3, b to the power 4, the whole thing squared. So there's an exponent 2 just for the numerator alone. Then in the denominator, okay, there's no bracket in the denominator, sorry, so just pretend as if this bracket just ends in the numerator. In the denominator, you have m to the power negative 8, n to the power 9. Okay. Okay, I'm gonna do, this will be the second last. Okay, let's just say third last. Okay, I'm just gonna do this one, then the next one, then a final one, and after that, the guys, I'm gonna give you a few to do on your own, in your own time, just for your own personal practice, and then I'll see you guys tomorrow. Well, I guess I'll see you when I see you. I may not see you tomorrow. It's Christmas. After all, I don't think people want me to be all up in their case on Christmas Day. People want to be present. Okay, but funny thing, people will be on TikTok watching other interesting things. Yeah, Lindelan. Yeah, we can, definitely. I'll chat to you later. 7a to the power -3, b to the power 4, or raised to the power 2 over m to the power -8, n to the power 9. Hey, Delani, don't make me laugh here. Why are you cracking me up so much? Could sir have one member request? I feel like gifting 10 roses to that brave soul. Which brave soul? Or the one who comes up and does it? Sekhametsi is feeling generous. It's like Sekhametsi is like what you might call Sekhametsi is Mr. Santa Claus. Mr. Santa. Alright, guys, you heard Mr. Sekhametsi. Me, I'll be happy to. If you want to guest request and come and answer the question, you can request. Sekhametsi wants to gift you. Yeah, Mr. Sekhametsi is saying it's Christmas. Oh man, this is so funny. It's crazy. No, Lindelani will talk in the inbox, my friend. He will talk in the inbox. You can just message me in the inbox. Send me a message there in the inbox, because yeah. Crash, just in case you are here, I moved the goalpost. I think I'm gonna have a live lesson with the grade 12s later on, not now. I just want to finish off a few problems with these. Then we'll have a lesson later on with the grade 12. Okay. No one wants to brave the storm, because Sekhamet was saying that wants to Hi man, leave him alone. Leave him alone. Wait for answer. Matata, maybe Matata wants to come. I think Matata wants Kijime. Kijam. You are crazy, you are so crazy, Rameez. You are crazy, man. You are crazy. Okay, let me write a few. Actually, let's write a few for you guys, because these are not mine, these are yours. So let's write a few. What's happening with Mavuso there in the comment section? Just thank the Lord. Oh man. Okay, there we have it, guys. There. No, Mavuso is in grade 10. Grade 10's coming up. Mavuso is going to grade 10 next year, I believe. Yeah, and this is just a general live for everybody who's anybody. Okay, yeah. Okay, so guys, there are 5 beautiful problems. The minute you feel like there's one that you want to showcase your brilliant skills in being able to do, let me have you a guest. You can request there. There's a guest request. You can just request to join so that I can invite you up, and then you can lead us through how you got to your answer. I think Mr. Sekhamet is ready to be Father Christmas and award you guys some nice, beautiful gifts. It seems like Mr. Sekhamet is very generous. He has been deployed by Santa Claus to come and gift those that are astute in maths. So yeah, fun in the sun. I am a woman, Hle. Oh, shame. I'm sorry about that. Mrs. Khessie Hameti. I'm very sorry about that. My mistake, my biggest fault. You see, the thing is, guys, if the profile pictures were as clear as they ought to be, then I wouldn't be making all these big mistakes. But you see, the thing is, some of our beautiful names that are here, they are, some are unisex, some are all sorts. So sometimes I make assumptions because I can't really see clearly. For instance, the profile picture, I don't even know what's happening there. I don't know. Miss Yehamete has a, yeah, you see, even that profile picture, it looks like a, I don't know if it's a witch. Hey. I'm just kidding. But yeah, anyways, John Maputla is in the live. My goodness, we have celebrities in the house. This is so amazing. How's it, John? Hey, I call. Yikes. Batunga, which, yeah. What is that? What manner of profile picture is that, Ms. Ramit? What manner of profile picture is that? Right, so any guest requesters? Guys, I'm waiting. I'm waiting. Yes, Lindelani, I'll have a live on the 26th of December. I'll have a live on the 26th of December. So, anyone, guys? 1, 2, 3, 4. Any of those questions are there to be answered. Anyone can request. Come on, guys. Come on. Don't be scared. Don't be scared. Nom, I think you are ready there. You have answers for us somewhere. Does my PFP look feminine or masculine? Let me see. Chica. Oh my soul. What in the world? I don't know. Feet together with the profile picture that says Chica with a shark. I don't know. I'm shocked. I just arrived. My mom called. Oh, okay. No, that's good. You are a very obedient child. When mom calls, you answer. Very good. I love that. Good job, nom. Or is it better yet, pretty babies? Nom or pretty babies? Which one is it? Okay, guys. Anyone? Man, I'm still waiting for that brave. But please, it has to be someone that's in high school, because some people are just gonna come in here. They want to come and, showcase their skill. But we are not dealing with a high school baby. We are dealing with someone who's been here. I'm full on Nomonde. Oh, okay. Full name is Nomonde. Sweet. I love the nom though. We are, I think. Why are you scared? Come, guys. Come on. Don't be scared. Yeah, you see now your Father Christmas is giving me all the gifts because you guys don't want to come and claim your own gifts. Eish, these people. No. Or is it Mother Christmas? I guess we can't say Father Christmas. You're gonna have to say Mother Christmas this time around, because Sekhamete established for me that it's not a he, it's a she. So Mother Christmas. We would, but we can't. We would, but we can't. No, you can. What do you mean we can't? What is this? What manner of speaking is this from Lindelan? Oh, Lindelan Kanene does not have Auntie Christmas. Suka Auntie. But some of you are using some of you have those privileges. I can see there. I can see. Look, for instance, Nom, I can invite up. Chick, I can invite. Jenino, Nesma, Sipo, Pretty Boy, Avakwan. All these people, there's people here that I can simply invite up. They have the invite tab there available. Alright, guys, just not to waste time, because I'm going to have a live with the grade 12s soon enough, and the thing is, time is not really for me here. Okay, so I would have obviously allowed for more time, but of course, guys, we look at this one: 7a to the power negative 3b to the power 4, the whole thing squared, over m to the power negative 8, n to the power 9. Just verify and check with your own answers if they are fine. Matata, remember, by now at least you should have gone further than number 1. Are you still busy with number 1, Matata? Is that why you are saying wait? Because I'm doing number 1. Are you telling me that I need to stop, not do number 1, because you are still busy with number 1? Ki matata fela. Ha, ki matata fela. Ha. Ki matata fela. Is that really your real name, Matata? Is that... Man, I'm sorry. It's just that sometimes You guys, I don't know. The thing is, some of you guys write names for the sake of writing names. You write names, and it's not your names. For instance, Pretty Boy Junior is definitely not Pretty Boy. I know that. Okay, Pretty Boy. You might find that Pretty Boy is actually not that pretty. That's the thing, because boys are not pretty. So. Yeah. You guys you're killing me there. You're killing me with these names. Okay. Anyways, like schism oh my goodness, you guys. No, I'm just kidding. Boys. Okay, so as said before, we apply BEDMAS. So that means we are going to apply the exponents. Cheers, chica. We apply the exponent to the bracket. Okay, so I can see there my good friend Matata. Here is an answer. So there we are going to say, we apply the exponent to the sign, the number, the letter. Because remember, brackets, exponents. Yeah, indeed you do. Indeed, which is fine. Squared. So that means 7 squared, a to the power. Remember, negative 3 times 2, negative times a positive is negative, and 3 times 2 is 6. B to the power 4 times 2 is 8 over m to the power negative 8n to the power 9. Continuing on, what's 7 squared? 49. Okay, then remember guys, we don't want to have negative exponents. So that means in the denominator, a to the power 6 is going to become a to the power negative 6 in the denominator. M to the power negative 8 becomes m to the power positive 8 in the numerator. Positions are changing so that we can have positive exponents. B to the power 8 is fine in the numerator. N to the power 9 is fine in the denominator. That is our final answer. 49m to the power 8. Remember, this changed position, moved to the numerator. The exponent sign changed from negative to positive in the numerator. B to the power 8 is fine in the numerator. N to the power 9 is fine in the denominator. A to the power negative 6 changes position, goes to the denominator. The exponent sign changes from negative to positive. So that is our answer. This is the answer for this guy. Okay, I hope that makes sense, and I hope we are clear. Okay, there are no additions of exponents because we don't have the same base in the numerator. Remember guys, we only add exponents when the bases are the same. This is base A, this is base B, this is base M, this is base N. The letters are different, so there's no subtraction of exponents that's going to happen. There's no addition of exponents that's going to happen because the bases are not the same. Okay, the bases are not the same. If the bases were the same, let's say if this was base A and this was also base A, we would multiply the bases and then add the exponents. But we can't do that because the bases have different letters. This is letter A, letter B, letter M, letter N. There cannot be any addition and subtraction of exponents happening here. All right? Yeah. Remember, the relationship between A and B is one of multiplication. So if the bases were the same, we would add exponents, but we don't do that because the bases are not the same. The law only applies for same bases. Okay, let's move on to this question. 3x squared y to the power 4 raised to the power 3 times 2y to the power negative 2x. So this here is a base multiplied by this one as well. But this bracket has an exponent. So BEDMAS says brackets exponent. So let's apply this exponent for this bracket. 3 is going to be what, guys? 3 to the power 1 times 3, which is 3 to the power 3. X is going to become 2 times 3. That's going to be 6. Y is going to be y to the power 4 times 3. What's 4 times 3? 12. You see, now I'm going straight to business, guys. I'm not wasting any more time by taking the exponent, showing that I'm multiplying it, because I know the law that I'm applying for this bracket with this exponent, because there's one term inside the bracket. Then we multiply that with 2y to the power negative 2x. Now we can multiply these two. When we multiply these two, remember, when we multiply, don't forget sign, number, letter. We multiply first what? The signs. But before we do that, what's 3 to the power 3? 27. Okay. Then we can now deal with multiplication of sign, number, and letter. This is a positive 27. This is a positive 2. What's 27 times 2? That gives us 54. That's sign and number multiplied, sorted, because a positive times a positive gives us a positive number, which is 54. Then we move on to the letter. X to the power 6 multiplied by x. Remember, this x has the exponent 1. So what do we do when we are multiplying same bases? X to the power 6 times x to the power 1. That means x to the power 6 plus 1. Then we move on to y. Y to the power 12 times y to the power negative 2. So we are going to say y to the power 12 plus minus 2. We are adding negative 2. Adding what? Negative 2. So finally we get 54x to the power 7. Then y to the power 12 plus minus. Remember, a positive times a negative gives you what, guys? That will give us a negative. So 12 minus 2, what does that give us? It actually gives us 54x to the power 7, y to the power 10. So that is what we basically do with this particular problem. That's how we solve, or we simplify, the exponent, the exponential expression. Okay, we multiply, we apply multiplication of the sign. Positive times a positive is positive. Multiplication of the number, 27 times 2 is 54. Then we multiply the letters. Same base, x to the power 6 times x to the power 1. When we are multiplying same bases, what do? We keep the base x. We add the exponent 6 plus 1. When multiplying same bases y, we keep the base y. We add the exponents 12 plus minus 2. Which is 12 minus 2, which gives us 10. 6 plus 1, which gives us 7 as an exponent. That's our final answer. Next question. Okay, so I hope you guys are seeing how simple and straightforward this is. Division. Division. X, X, Y, Y, Z, Z. Division. BEDMAS. Brackets? No. Exponents? Yes, for the individual letters. Move on to the next letter, D. Division? Yes. division using S and L. Division using S and L. So let's write this question, guys, so that you can x to the power 3 y to the power negative 3 z to the power 7 over x to the power negative 1 y squared over z to the power negative 4. Bed mess. Brackets, no brackets. E, exponents. We do have exponents, but not for a bracket, so we move on. D, division. Is there any division here? Yes. The line means divide. So when we divide, we consider the sign, the number, the letter. Sign, number, the letter. So division of what? Of same bases. The sign, no signs. Positive divided by positive is positive. Number, we have 1 and 1. 1 divided by 1 is 1. Letter, these 3 letters, X, Y, and Z. So what do we do when we are dividing same bases? DK, we subtract the exponents. Thank you very much. You are very much correct. So we're going to say x to the power 3. The divide sign means subtract, but this is negative 1, so it's minus 1. Do you see that, guys? Do you see that? Hey, I hope you see that, guys. Y to the power negative 3 minus 2. Z to the power 7. But we subtract negative 4 minus negative 4. Okay, I hope this is making a bit of sense. X to the power 3 divided by x to the power negative 1. If we apply the law, it means we're going to say x to the power 3 minus this negative 1 minus the negative 1. But what does that actually mean, guys? What's a negative times a negative? That actually means we are saying 3 plus 1. Thank you, DK. You are 100% correct. A negative times a negative will give us a what? A positive. All right. Okay. Okay, does that make sense, guys? Okay, I hope it makes sense. Negative times a negative is a positive. Positive what? Positive 1. We move on to y. Negative 3 minus, all right, because of the division, the 2. 3 minus 2, negative 3 minus 2. I mean, that still is what it is. Come here to the z. Z to the power 7 minus the negative 4. In other words, what's a negative times a negative? Z to the power 7 plus 4, because a negative times a negative is a positive. I want you guys to soak this in and take it in and take it in. Final answer. Negative 3 minus 2. Guys, whenever you are at loss with this addition and subtraction of integers, I would hope that you would simply just use your calculator, because many times students fail to actually know how to add and subtract numbers, and I don't know why. But grab Mr. Calculator when all else fails, guys. Grab him, put him the number, get him the answer, and move on. Okay, do not waste time and do not mess up the addition of integers or subtraction of integers because you are lazy, capezi. Okay. Z to the power 11. Final answer, x to the power 4, z to the power 11, y to the power 5. Why is the y not negative anymore but positive exponent in the denominator? It's because, remember, we are using that law. When a base is raised to a negative exponent, we do not want to leave our answer having a negative exponent. So we know that the position of the variable changes from the numerator to the denominator, and then the sign that is negative changes from that to positive. That's why we have y to the power 5. That's very important, so that at the end of the day, we do not leave our answers having a negative exponent. Okay. Let's do number 5 and then we'll close with number 4. Let's do number 5, then we will close off with number 4. And guys, that's it for the evening. I think, yeah, that is like a overdose of exponents. My battery as well is dying here. I don't know, didn't anticipate that it would die like this, but it's dying, it's dead. I don't want to be charging my phone whilst I'm busy with the live, because that just leads to other problems. Yeah, let's look at number 5, and then after that we'll do number 4. So I'll do number 5 first and we'll do number 4. But look at number 5. In the numerator, what do you see? Can you see what I see? Because if you are a bad maths person, you first start looking at what is inside the brackets, and the minute you look at what is inside the brackets, you soon discover that there are things that can be done. Look at the numerator alone. What do you see, guys? Tell me what you see in the numerator. Just the numerator. Forget about the brackets. Thank you, Matad. I see like terms. Me, Matata, I see children with the same uniform. 2 children that have the same uniform. Why do I know they have the same uniform? It's because x has an exponent 3 and this x has the exponent 3. That's how I know they have the same uniform exactly. Right? Yes, no, there's an invisible one. I love that too. When I Nom, you are amazing. Nom, you are so amazing. So there's an invisible one that we cannot see, but it's there. So these are like terms, and we know what we can do with like terms. Like terms, there's something we can do with them. Look at the denominator. What do you see? You see? So that's why I'm saying, if you are going to be looking at B for brackets, there's things we can do inside the bracket itself. Let's do those things. Let's do those things. Yeah, I'm teaching the worst subject to the best of the best learners that you can ever find in this TikTok space, Mosamus. Okay. Yeah, and I'm sorry that maths has hurt you. I'm sorry for what it's done to you. Let me apologize for and in behalf of, let me extend that apology that you've always wanted in your heart. I'm very sorry what maths has done to you. If it is someone that was teaching you that must have also contributed to how you feel, I'm very sorry. Very, very sorry. Hope your heart heals. Okay. So 1x to the power 3 plus 2x to the power 3. In the numerator, we have like terms. In the denominator, guys, we have x times x. There's something, okay, we can do. Jojo, I rebuke. Oh, my soul, this is so funny. Take it away, Jojo. Jojo, your profile picture is so dark, bro. What is happening? Oh, my soul. People like, you guys, I'm sure that is someone else's face. It's not even Jojo's face. Jojo, how, I don't understand what you guys do. So rude, but like, I mean, really, you are the one that's coming into this live and you are saying damn it in my live, you know, spewing all sorts of things. So rude yourself. I think, my friend, let us nullify Okay, yeah. Okay, so there we go, guys. Jojo Tank. I God forgive us all. So in the numerator, guys, we can definitely add the like terms. Okay, so that's why in brackets, if there's something we can do in the numerator, let's do it. So whenever we are adding like terms, what do? We keep the variable exponent, which means we keep x to the power 3. So x to the power 3 is going to be kept. Then we add the coefficients. What's 1 plus 2? It's 3. Okay, very good. Then we go to the denominator. X times x. Guys, when we are multiplying same bases, what do? We keep the base. We add the exponents. We know most the exponents that are there are 1 and 1. So when we multiply same bases, we keep the base. We add the exponents. What's outside? There was a 2 that was outside there. You see? Now, let us divide what's inside the bracket before we even apply the exponent. You see, we're still dealing with the bracket. So we are still there at B. But we are doing all sorts of things there at B. Okay? No, that's fine. Your mind must shout December. Because when you are in school, your mind shouts December. When you are... so it's okay. It's okay if your mind is shouting December. 3x cubed over x squared, guys. 3x cubed over x squared. Right? Now we can just do what? Divide. Okay? 3 divided. Remember, there's a coefficient there of 1. So when we divide, we apply sign, number, letter. So 3 divided by 1 is 3. Then we move on to the letter. X to the power 3. When the bases are the same and you are dividing, what do you do to the exponents? We subtract. Okay? Does that make sense? All raised to the power what? 2. So we get an answer of 3x to the power 1, which is all raised to the power 2. Okay? Does that make sense, guys? Go talk to your family, or do you not have anything else to do on this Christmas Eve, CJ? Oh, this is so funny. CJ, you're the best. All right, and then finally, guys, okay. My family knows that I need to play Santa tonight to those kids that, their greatest wish in their heart is for them to actually start figuring out this maths. So that's why I'm here. I'm playing Santa Claus this evening. So my family understands that mission. I hope that clarifies your question there. 3x to the power 1 raised to the power 2, guys. Finally, we can just apply the exponent inside the bracket. Does that make sense? What do? We distribute the exponent. All right? And then we get an answer of 9x squared. Right? You see that law? One base, we distribute the base, the exponent, to the exponent 1 for base 3. 1 times 2 is 2. And then we distribute the exponent 1 times 2 is also 2. Then we know that 3 squared is 9 and x squared is obviously x squared. So therefore the answer is 9x squared. So guys, that's simply using what? Using BEDMAS. Okay? And we simplify and we get to the answer, and it's just that. Yes, Matata, I do. And there's a fee attached to joining the WhatsApp group. You can speak to your parents about it. You can DM me, send me a private message. We can talk about it further there, okay? Especially in the coming year, because I'm doing things a bit differently than I did them last year. The previous year, 2024, leading to 2025, everything was just freebies, free rolls. But I have to do things a bit differently because I have a family to feed. Okay, hope that makes sense. There, 9x squared. So guys, I hope that is clear for you. All right, last question, last question for the day. A plus b over a to the power negative 1 plus b to the power negative 1. I would be happy to have someone come and show me or show us how we do this one. Right, I know how to do it, of course, but it would be nice challenge question. A plus b over a to the power negative 1 plus b to the power negative 1. I enjoy doing this one. Maybe Sekhamedzi, the mother of Mother Christmases, can finally come through. Matata, finally someone asked. I do have WhatsApp groups. Of course I do. Okay, that's why I can tell you that I have people that have, like I said, some of my kids that are in my WhatsApp groups that were part of the groups last year. I can share with you many testimonies, concerning how they have performed last year and so forth. So yeah, please me, Alpha X Music. Oh, you want to answer it, Alpha X? Okay, Alpha X, you can come through. Yeah, please me. Let's please you. Come through. You can lead me along. I'll be happy. Alpha me.
Yes.
You are Alpha.
Yes.
When is the Omega happening?
I don't really know.
I don't really know. All right. Let's
Yes,
do this, man.
but
Let's do this.
okay. So, according to what you have taught,
Okay.
so when the A is single, doesn't have any power, it's A to the power of 1. And then you have to say A to the power. When we are dividing, you subtract the exponents. A to the power of 1 minus negative 1, which is equals to positive, which is equals to A squared plus B
Okay. So
over B
so
to
you
the
say,
power of negative 1.
okay. Is that
Yes.
what you said? Okay.
Yes.
Okay.
And then, since B doesn't have any power, it's B to the power of 1.
Okay.
So when you are dividing, again we said you subtract the exponent. Since there's a negative, we have to add.
Okay. So
B to the power of
in other
1
words, you're
plus
saying
1,
it's 1 plus 1
which is
e
equals
to the
to
power 1 plus 1.
Yes, in each our answer we get A squared plus B squared.
Okay. So is that
Yes.
what you got?
Yes.
Okay.
Yes.
All right. I hear you. I hear what you have done. But the problem is there's a problem, and I'll tell you where the problem is. All right. But
Yes.
I love your
Yes.
attempt, and I love the fact that you have there's elements of what we have looked at today that you have applied. But the only problem here
Yes.
is that unlike all the other problems
Yes.
that we were doing, I want you to pay attention. Do you see this problem here? Look at
Yes.
the variables. Look at your variables in the numerator. What relationship does X, Y, and Z have? What relationship do they have? Do you know?
They are numerator. Yes, numerators.
They are in the numerator, but what relationship exists between X and Y and Z? What combines X, Y, and Z?
Multiplication.
Exactly. And this is what is very important. So here, X, Y, and Z are combined by multiplication. Look at the denominator. What relationship exists between X, Y, and Z?
They are multiplied together into making
Exactly.
X, Y, and Z. Yes.
Amen. Now, because of that relationship that exists at the top and at the bottom, because of
Yes.
that, it's easy to then apply our law for division. because all these bases are simply combined together by multiplication. Okay?
Yes.
Yeah.
Yes.
But this problem, this one, is a bit different. Look at the numerator for this problem. What do you see?
Yes. I see they are uncombined because there's an addition sign in which it does
Amen.
not.
Amen, my brother. That you see that part that you've just said. The numerator here
Yes.
is separated in terms. There's term
Yes.
A and
Separated.
there's B. And you look at the denominator as
Yes.
well. What's happening here?
Yes. They are
They
separated.
are also exactly. Now, because of that, I cannot take this A and divide it by A to the power
Yes.
negative 1 because of this
Yes.
separation.
Yes.
I can't do that. So I'm going to have to think of another way to simplifying this particular problem. So doing it this way
Yes.
is incorrect. Why?
Yes.
Because of these separators in the numerator and in the denominator.
Yes.
But if there were no separators, if there was the combining operations like multiply and brackets, we would have just done it like the way you have explained. It would have been fine and it would have been
Yes.
100% correct. But because of the fact that there
Yes.
is no what, there is no multiplication between the bases, we cannot approach this problem in the same way as this one.
Yeah.
Yeah. So I hope for you can allow this moment to be a good teaching moment for yourself. All right. It's more important that you learn than
Yes.
it is that you get things right for now. But once you understand, then I hope that in the future you will never find yourself doing something like what you've done now. But it's okay. I hope Alpha, you are not you are not
Yes.
discouraged. All right? But you are
Yes.
encouraged. Yeah.
Yes.
Yeah. So do you want us to walk through how we would approach this problem, how we would do it?
Yes,
Or do you
nigga.
have an idea, or maybe do you have any other thoughts that are different from how you have done it that you'd like to apply?
I just want to know how we can get with this.
Okay, all right. Yeah, please, my brother, don't be discouraged, ne? Please be encouraged. Be encouraged. Please be encouraged.
Yes, nigga.
I don't
Yes,
want
nigga.
you to leave this
Yes.
live and feel like, I couldn't do that problem. No, you attempted it, and that in and of itself is amazing. In actual fact, just your courage. There are 150 people in this live that are watching, and you had the courage to stick out from everybody else and attempt to answer the question. That in and of itself is commendable, and I applaud you.
Yes.
I applaud you too
Yes.
much. Yeah. So let's
Yes.
do it. Yeah,
Yes.
we can do this one. It's doable. It's nicely doable. So if you look at A plus B, that is fine there at the top. A plus B is just A plus B. We leave it like that. A to the power negative 1. You know, most there's a definition that says when you have a base raised to a negative exponent, you can write most that base
Yes.
as 1 over that variable, right?
Yes.
So A to the power negative 1 can be written as 1 over A. Also,
Yes.
B to the power negative 1 can be written as 1 over
1 over B.
exactly
1 over B.
Okay.
Yes.
Now, I just want now for you to consider the following. So this means that we have A plus B. All right.
Yes.
A plus B. Then this line means what? It
Yes.
means divide, right?
Yes.
Yes. So I'm just going to separate these things so that you can see them. This means divide by 1 over A plus 1 over b. Now, I want to ask you, Alpha, do you know how to add fractions? Because I want you to help me to add these two fractions, 1 over a plus 1 over b. Okay, do you know how to add fractions?
Yes, but these two are not edible because they are not like terms.
Okay,
These
they are
two,
not
1 over
edible.
a, 1 over b. Yes, they are not like terms. They cannot
Okay,
be
all right.
added.
All right. But
Yes.
what allows us, or what helps us to be able to add fractions? Let's just say, my friend, we had 1 over 2 plus 1 over 3. Can you add these fractions?
Yes, you have to find a factor that 2 and 3 can get into, which is 6. 1 over 2 plus 1 over 3 is 5 over 6.
Okay. Oh, it's 5 over 6. So you already know what the answer is. Okay, how did you
Yes.
get to the answer, my friend? You
Yes.
said the first thing you said you need to find the what?
You need to find a factor where 2 and 3 can get into.
Okay, and that is what?
6, nigga.
All right. So we have to find the LCD, as you said, the lowest common
Yes.
denominator. Yeah.
Yes.
So that number,
Yes.
as you said, is called the lowest common
Yes.
denominator. So obviously that LCD, if we multiply the denominator here by 3, we get that LCD. We do the same thing to the
Yes.
numerator. If we multiply
Yes.
what do we multiply 3 by to get 6?
You multiply 3 times 2.
Thank you. So
Since
we
3
will do
is
the
twice the
same.
number.
Exactly. And then we'll do the same in the numerator. Right? Then finally, 1 times 3 in the numerator is going to give us what?
1 times 3. It's
Yeah.
going to give us 3.
And then in the denominator, we have that LCD that you spoke about.
Yes, nigga.
Okay, then finally, the final answer is going to be 5 over 6, as you have explained
Yes.
and clarified earlier on.
Yes.
Okay, I see people in the comment
Yes.
section saying you can also use the butterfly method, and I like that because that's very true. So the butterfly method, for those who are wondering what do these people mean by butterfly method, guys, this is the butterfly method. The 3 gets multiplied with the 1, the 2 gets multiplied with the 1, and then the 2 and the 3 get multiplied with each other. So if you do this first, 3 times 1, you have 3 there. And if you do that 2 times 1, you have 2 there. And then in the numerator, 2 times 3, you get 6. So the final answer is 5 over 6. The butterfly method also works. Okay? Those people who are saying the butterfly method in the comment section. So we're coming back here, and I was saying, how do we add 1 over a plus 1 over b? We find the LCD.
You look. Yes, which is equals to AB. A times B, which is
Exactly.
equals to AB.
Okay, but if we use that butterfly method as well, b times 1, we get b. A times 1, we get a. And then lastly, in the numerator, a times b, we get ab. So the butterfly method also works. All right.
Yes.
So we have b plus
Yes.
a over ab. Okay.
Yes. New ability
And then we have
gained. Butterfly method.
ability gained. Amen. Amen. I love
Yes.
that. I love that. Okay. Now
Butterfly
remember, guys,
method.
butterfly method. Yes, butterfly method. for two fractions. It only works when we have an addition and a subtraction of two fractions. That's where the butterfly method works. But if you have 3 or 4 fractions that you have to add and subtract, unfortunately, you are going to have to use a method like finding the LCD and then finding the equivalent fractions for each fraction that you have there. Okay. Anyways, this divide, we know most when we are dividing two fractions, we can change the divide to what?
To multiplication.
Exactly. What do we do with the fraction that follows that multiplication?
We invert the fraction.
Thank you. You see, you are using big words. Invert the fraction. Guys, did you hear that? This man is not using a light term vocabulary for maths. He's using big terms. We invert, we flip the fraction. So for us layman term people, we like the word, we flip the fraction. But as you heard, alpha is not playing around. We invert the fraction. Okay. Then we must simplify. This a plus b and this b plus a, we can do what to them? This divided by that. This
it's
divided
1
by that. Exactly. Okay.
It's 1.
And then we can see that there's no other relationship that we can see. So we multiply the numerator and we multiply the denominator. What's 1 times AB in the numerator?
1AB or just AB.
Thank you. And then in the denominator, we have 1 times 1.
It's 1.
Which is just 1. And then finally, AB
1.
over 1, we know the answer is what? It's AB.
AB. Yes.
So this is how we go about attending this particular question. So that's why I was saying to you earlier on when we were doing exponents, that it's very important that when you do exponent questions, first analyze the expression that you have been given and check how many terms do you have, so that when you are able to see the situation in the particular problem, then you can attend it in a way that is suitable and then be able to actually work through it and get to the answer. So this is how we would do this one. But I'm glad, Alpha, you had the courage to come on here and actually do this problem the way that you did it, so that we could learn from the situation that you had presented. It's good, and we thank you for it. You are the man. Okay. Are you a musician or something?
No. I'm no.
Oh, okay. I thought a musician. I thought I saw this Alpha X music. I thought maybe you are doing the thing. You are dropping some serious, albums during the festive season. Maybe you are performing in serious places. I don't know, So that's why I'm asking. All right.
Yes. But it was a nice tutor. It was a nice lesson.
Too much, my brother. Thank you so much for joining in. I really appreciate you. You taught me something
I
as
want
well.
Another lesson tomorrow.
Hey, the part you're like, you want another lesson. You guys need to learn the art of asking with a nice please. You guys just demand. Every time I go live, people just say, I want, I must have, you must go live, you must do this, you must do that. You could swear you guys are paying me like big money to just be here and do live lessons. So you kill me when you do these requests. I hear you, bro. I hear you, buddy. No,
yes, please. I want another one after Christmas.
Don't worry. I'll be here, my brother.
I want to be 4 times ahead.
No, that's fine. That's fine.
Yes, what grade are you doing?
What grade will you be doing next year?
Grade 9.
Oh, grade 9. Don't worry. Don't worry, my brother. Don't worry. Don't worry.
Yes. Thank you.
Okay, well, thank you, thank you, thank
Yes.
you. Cheers, eh? All right, that was sweet. That was sweet. Good man, good guy, good job. Well, guys, that was it for today. Thank you, thank you, thank you. You guys were great sports. It was awesome, awesome, awesome. We'll see each other again. I just have to bounce now because yay. But the maths is bombastic. So someone said they don't understand. Don't understand what now? Oh, guys, my battery is crazy dying right now. Oh, my soul. I'm gonna have to charge my phone. It's gonna die, 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 die.